Hello, and welcome to Sleep Gravity. In 2012, a small spacecraft built by human hands sent a quiet message back to Earth from a place no hand had ever touched. It did not send back a brilliant photograph. It did not reveal a cosmic doorway opening in the dark, nor did it announce that it had crossed some outer wall of the solar system. What returned was only data, numbers, fluctuations, tiny changes in the flow of particles and in the plasma environment around the spacecraft. But to scientists, those faint signs were enough to say that Voyager 1 had passed through a boundary humanity had once only been able to infer on paper. It had entered interstellar space, where the solar wind no longer held the same dominance it once did. The strange thing is that there was no single moment that looked like a border crossing in a film. No light flashed around the body of the spacecraft. No thin line stretched across the darkness. Voyager did not pass through a door, but through a very slow change in nature. Behind it was the region where the sun could still breathe its stream of particles outward into space. Ahead lay the medium between the stars, extremely thin, extremely cold, but not completely empty. If a human being could stand there, their eyes would probably still see only darkness and distant stars. The real boundary would not appear to sight. It would only appear when we learned how to listen to matter. For a very long time, the solar system has often been imagined as a family, with the sun at the center and the planets orbiting around it. That image is correct, but incomplete. It is like looking at a city as points of light on a map while forgetting the wind, the sound, the temperature, the movement of people, and everything flowing between the streets. The sun does not only hold the planets with gravity, it also continuously releases charged particles, creating an invisible wind that spreads in every direction. That wind passes Earth, passes Mars, flows through the realms of Jupiter and Saturn, continues beyond the distant ice giants, and then slowly weakens as it meets the material between the stars. If we only ask where the last planet lies, the answer is relatively easy. Neptune is the farthest major planet in the main planetary system, and beyond it lie icy bodies, long and cold orbits, and small objects for which sunlight is only a weak source of brightness in the sky. But the question, where does the solar system end, cannot be solved simply by counting planets. It goes deeper than that, because the sun has many ways of touching the space around it. Its light travels very far. Its gravity still holds objects at enormous distances. Its particle wind creates another kind of boundary, a place where the influence of the star begins to give way to the environment of the galaxy. That boundary is called the heliopause, which can be understood simply as the place where the bubble of the solar wind reaches its limit. Inside that region, particles from the sun are still the main flow. Outside it, the material between the stars begins to play a larger role. The name may sound like a stopping point, but in reality it is not like a cliff or the edge of a table. It is more like the waters where a great river empties into the sea, where the old current does not disappear at once, but has already begun to be changed by the salt, the depth, and the motion of the ocean. If we try to draw it as a sharp line, we lose its true nature. The edge of the solar system is not a perfect outline, but a region of negotiation between the sun and the galaxy. Voyager 1 helped humanity understand this in a very patient way. The spacecraft was launched in 1977, in an era when many instruments we know today did not yet exist. It flew past the giant planets, using their gravity to gain speed, and then continued moving away from the sun for decades. When the planetary images had ended, its mission did not disappear. It still carried instruments to measure particles, magnetic fields, and cosmic rays, recording changes the human eye could never see. Those instruments turned a small spacecraft into humanity's ear in a very distant region. Near Earth, the solar wind is a familiar part of the space environment. When it grows stronger, it can make auroras shine more brightly, affect satellites, disrupt communications, and remind us that the blue planet does not live apart from its star. But as that wind moves farther out, it pays the price of distance. It cannot keep its strength forever. The material between the stars, though incredibly thin, has its own pressure. The galaxy's magnetic field also has its own direction and structure. Cosmic rays from distant events in the Milky Way still stream through the emptiness. In the outermost region, these factors begin to push back against the flow of particles from the Sun, giving the star's bubble a shape, a shell, and a moving boundary. One of the easiest misunderstandings is to imagine interstellar space as an absolute void. If it were truly empty, the solar wind might spread in a different way. But the galaxy is not an abandoned room. Between the stars, there is extremely thin hydrogen gas, helium, fine dust, magnetic fields, and high-energy particles born from stellar explosions and violent phenomena far away. Each cubic meter of that space contains very little matter compared with anything on Earth, but across scales of billions, even tens of billions of kilometers, that very little still becomes an environment that can interact, resist, and shape the Sun's sphere of influence. So the edge of the solar system is not where the Sun suddenly disappears. It is where the Sun's voice grows softer inside a much larger room. The solar wind still carries the trace of the star that created it, but the farther it travels, the more that trace is mixed with the galactic environment. At a great enough distance, Voyager's instruments began to record the change. Particles from the Sun decreased, cosmic rays from outside increased, and the plasma environment around the spacecraft no longer resembled the region inside the solar bubble. There was no spectacle to admire, but there was a shift in tone in the music of space. This makes the original question much more beautiful than a simple number. Where the solar system ends is not only a question of coordinates, it is a question of how the influence of a star fades. Sunlight can keep traveling through the darkness for years, centuries, and millennia. The Sun's gravity still holds distant comets at the outermost reaches of the system, but its particle wind has a clearer limit, where it meets the material between the stars and can no longer expand as freely as before. If we look at the solar system through light, we find one kind of boundary. If we look through gravity, we find another. If we look through the solar wind, the heliopause becomes one of the strangest borders humanity has ever measured. There is a peculiar humility in this discovery. Human beings thought about the universe with their eyes long before they learned to measure things the eyes cannot see. We looked at the planets, gave them names, calculated their orbits, and drew neat diagrams in books. Then, layer by layer, science showed that our home is not as tidy as those drawings. It has particle storms, magnetic fields, interplanetary dust, distant icy regions, transition layers, and boundaries that cannot be seen in ordinary light. The solar system is not a clean model placed on a classroom desk. It is a living environment, moving through the galaxy, shaped by the Sun and also affected by the space around it. If the entire solar system could be reduced to an image easier to feel, the Sun would not look like a sphere standing in an empty void. It would be more like a flame swimming through an almost invisible ocean. That flame does not only shine, it also creates around itself a region of warmth, a layer of motion, a boundary where its heat meets the cold flow of the deep sea. Earth lies deep inside that region, close enough to the source of light that every day we live with its rhythm of rising and setting, rarely thinking about the distant shore. Voyager is one of the rare things that has drifted close to that shore, far enough to begin hearing the galactic ocean more clearly. Here, the strangeness does not come from danger or from a violent scene. It comes from the softness of a boundary too large to grasp. Human beings often prefer concepts with clear edges, because clear edges make the world feel easier to hold. But the heliopause teaches a different lesson. Some borders exist only as a balance. On one side, space is more strongly influenced by the Sunday. On the other, space carries a more clearly interstellar character. In between is a transition region where everything shifts, bends, compresses, and changes over time. The Sun's activity rises, and falls in cycles, and the outside environment is not perfectly uniform either. So this boundary does not stand still like a line drawn on paper. What is remarkable is that Voyager did not see the heliopause. It sensed it through the changing character of the environment. In that way, the discovery resembles many experiences in modern science. We do not see gravity, but we see orbits curve. We do not see charged particles with the naked eye, but we see auroras and signals in instruments. We do not see the interstellar medium as a thick mist, but we see how it changes the particle flow around a spacecraft. The universe often does not speak in direct images. It leaves traces, and human beings learn to read those traces more slowly from one generation to the next. From that perspective, the edge of the solar system is not just a distant place meant to satisfy geographic curiosity. It is proof that we are living inside a structure created by the sun. Every day, the light of that star makes leaves open, warms the air, lifts water into vapor, and keeps the biological rhythms of living things in motion. On a larger scale, the sun also creates a bubble of particles and magnetic fields around the planets, helping shape the space environment in which Earth exists. We do not feel that bubble in everyday life, but it is still part of our cosmic home. Only when a spacecraft travels far enough do we realize that this home has an outer shell. Then the question returns, but it is no longer as simple as it first seemed. Where does the solar system end? Perhaps the first answer should be this: it does not end in only one way. It fades in several different ways. The major planets end in one region. The solar wind ends in another. The sun's gravity reaches much farther still, toward distant clouds of comets. Each boundary tells a different part of the story of our star. The heliopause is only one of those endings, but it is the most special one when we ask how far the sun can still breathe its wind into space. When Voyager crossed that boundary, it did not completely leave behind every connection to the sun. It was still influenced by the sun's gravity. It still saw the sun as a bright star in the space behind it. But the environment around it had changed. The enclosure made by the sun's particle wind had given way to the thin material of the galaxy. A spacecraft born on Earth, launched from the region near the sun, had become the first human-made object to listen to interstellar space from within. That thought alone is enough to give this boundary an unforgettable quietness. That quietness is exactly the right way to enter this subject. There is no need to imagine an apocalyptic scene at the edge of the solar system, and no need to turn the heliopause into a mystical wall. The real science is already deep enough. A star blows wind into space. An invisible bubble, larger than every planetary orbit, takes shape. An interstellar medium that is almost empty still has enough presence to apply pressure. A small spacecraft flies for decades to detect the place where two physical worlds meet. These elements are not loud, but they have a lasting pull, because they remind us that even the word end is not simple in the universe. In the farther parts of this journey, the solar wind will be seen more slowly, from its origin on the restless surface of the star to the way it spreads through space. The heliosphere will become clearer as the sun's own shelter within the galaxy. The outer layers, such as the termination shock, the heliosheath, and the heliopause, will be separated little by little, not as dry terms, but as different regions in an invisible ocean. Then Voyager will return, not only as a name in the history of space exploration, but as a quiet witness to a larger question. When does a place stop belonging mostly to the sun and begin to belong to the stars? Perhaps it is the absence of a line that makes this boundary so memorable. The solar system does not end like a book closing. It is more like a voice growing distant, a breath becoming thinner, a warm region dissolving into the cold ocean of the galaxy. At the center of it all is the sun, so familiar that it is sometimes taken for granted. But when seen from the farthest edge of that breath, the familiar star becomes something entirely different. It is not only the source of daylight, it is a force that gives shape, a center extending its influence into the dark, until the darkness between the stars begins to answer. Voyager's signal from the distant reaches told humanity that the sun has a very long breath. To understand the boundary where that breath begins to fade, we need to return to its source, not by taking a journey back to Earth, but by looking directly at the star that has quietly shaped the entire region of space around the planets. The edge of the solar system cannot be understood if we only look at the farthest place. It begins somewhere extremely hot, extremely bright, and extremely unstable, where matter no longer behaves like the familiar things on the ground. The sun may seem steady when it appears in the sky, but the sun itself is a gigantic mass of plasma that is boiling, rotating, vibrating, and constantly changing. Plasma can be understood simply as a state of matter in which charged particles are no longer held in place within ordinary atomic structures. There are electrons, protons, and particles slightly lighter or heavier, moving at very high temperatures, being pulled, pushed, and bent by magnetic fields. The sun is not a ball of fire in the ordinary sense, because fire on Earth needs air in order to burn. Our star shines because of nuclear reactions deep in its core, while its outer layers are made of materials so hot that magnetic fields and charged particles become the main language of motion. From the outermost region of the sun, especially the corona, some of this material does not remain with the star forever. It escapes outward, drifts away, and expands into space. This is the solar wind. The name may make it sound like a gentle breeze, but it needs no air, has no smell, makes no blowing sound, and does not make objects tremble the way wind on Earth does. It is a stream of charged particles made mostly of protons and electrons, along with a small portion of helium particles that have lost their electrons. Those particles do not fly away like dust shaken from a quiet surface. They come from an environment that is being heated, expanding, and guided by magnetic fields. What makes the solar wind special is not only that it moves quickly, but that it carries the trace of the sunday. When the particles escape, they do not simply rush away along clean, straight paths. Because they are electrically charged, they are affected by magnetic fields. The sun is also rotating, so its magnetic field lines do not stretch outward like evenly pulled threads. Instead, they are wound into a broad spiral shape in space. The stream of particles follows that structure, creating an image very different from the way we usually draw light spreading evenly around a star. Light moves outward, almost straight, while the solar wind carries a directed motion, a twist, a rhythm, and regions of different speeds, like an invisible map expanding with the rotation of the star. Near the sun, everything happens more violently than human intuition can easily grasp. The corona looks faint to the eye during a solar eclipse, yet it is unbelievably hot. That unusual heat is one of the major problems in solar physics. The visible surface of the sun is already extremely hot, but its outer atmosphere is much hotter still. From there, particles are accelerated, plasma streams escape, and gradually the solar wind spreads through all of interplanetary space. Human beings once could only infer this process from far away, through telescopes and measurements taken near Earth. Today, Parker Solar Probe flies closer to the sun than any spacecraft before it, entering the region where the solar wind is still being born and accelerated, so it can directly measure things that once appeared only in models. There is an interesting reversal in the way science explores the edge of the solar system. Voyager travels very far to listen for where the solar wind ends. Parker Solar Probe travels very close to understand how it begins. One aging spacecraft drifts through the cold outer region, another rushes through the hot inner region, and between those two extremes lies the entire story of the sun's bubble. When the pieces of data are brought together, we realize that the solar wind is not a simple background layer, but a flow that changes with time, with the regions where it emerges from the sun, with the star's activity cycle, and with unusual eruptions. The solar wind is not always the same. Some faster streams often escape from regions called coronal holes, where magnetic fields open more easily into space. Some slower streams are related to more complex regions near the sun's equator, and to curved magnetic structures. From time to time, the Sun also releases much larger clouds of material, like eruptions of plasma and magnetic fields hurled into space. These events are not the normal background wind, but they move through the same environment, giving the solar wind a kind of weather of its own. For that reason, the space around Earth is not a silent, static emptiness. It has calm days, disturbed days, and waves of particles and magnetic fields moving through on a scale larger than any atmospheric storm on the planet. Earth lives inside that wind every day. Fortunately, our planet has its own magnetic field, creating a protective region called the magnetosphere. When the stream of particles from the Sun comes close, most of it is deflected around Earth, like water flowing around a stone in a current. That image is not perfectly accurate physically, because this is plasma and magnetic fields rather than water, but it helps convey the main idea. Earth does not let the solar wind fall directly onto the ground like rain. The magnetosphere absorbs much of that pressure, bends the particle flow to either side, and stretches into a magnetic tail on the side facing away from the sunday. Even so, some of the energy still finds its way into the polar regions. There, charged particles follow magnetic field lines and collide with atoms and molecules in the upper atmosphere. Those collisions create auroras, bands of green, red, and violet light moving across the northern and southern skies. Auroras are so beautiful that it is easy to see them as a pure performance of light, but behind them is evidence that Earth is in dialogue with the sunday. A stream of particles from a star about 150 million kilometers away can make the upper atmosphere glow. Within the softness of the aurora is the trace of a space environment that is not empty at all. The presence of the solar wind also reminds us that the solar system is a place with weather, though this weather is not like rain and sunshine in everyday life. Space weather can cause satellites to malfunction, interfere with radio signals, affect navigation systems, and even influence power grids in strong cases. These details do not need to make the story tense, because most of the time, Earth remains very well protected. But they help us understand something important. The sun does not only shine from far away. It touches the environment around Earth with particles, magnetic fields, and energy. Life on the ground unfolds under the roof of the atmosphere, and that roof itself lies inside a wider region shaped together by Earth's magnetic field and the solar wind. If we follow that wind farther outward, the planets begin to appear not only as spheres orbiting the sun, but as worlds immersed in the same thin stream of material. Mercury is so close to the source of the wind that its surface and surrounding environment are more directly affected. Venus does not have a global magnetic field like Earth's, so the way it interacts with the solar wind is different. Mars also tells an important story because its thin present-day atmosphere is connected to the loss of its global magnetic protection in the past, allowing the solar wind to contribute to atmospheric erosion over long periods of time. Farther out, gas giants such as Jupiter and Saturn have very strong magnetic fields, creating vast and complex regions of interaction where particles, moons, and rings all take part in an electromagnetic system that is difficult to see with the naked eye. Because of the solar wind, the solar system is no longer a static diagram with circular orbits around a bright point. It becomes a continuous environment where the planets all lie within a flow coming from one star. The distances between the planets are enormous, but they are not entirely meaningless. They are connected by light, gravity, dust, electromagnetic fields, and streams of plasma. Human beings often speak of space as emptiness, but for the sun, that emptiness is the place where its influence is spreading outward. Air does not need to be present for a wind to exist. In space, wind is written in charged particles. The farther outward it travels, the thinner that wind becomes. Part of the reason is that it has to spread across an ever larger area, like a thin mist being stretched over an enormous sphere. Near the sun, the stream of particles is denser and carries stronger energy. In the outer regions, The same amount of material has to occupy a much larger volume. Each particle is farther from the next. The flow is still there, but the sun's voice becomes thinner, more diffuse, and more easily changed by the environment outside. This is the first step toward understanding why the heliopause exists. Anything that spreads farther and farther must eventually meet the limits of itself. That limit does not come from the sun suddenly running out of strength. It comes from the meeting of two environments. Inside, the solar wind pushes outward. Outside, the interstellar medium contains thin gas, dust, magnetic fields, and cosmic rays. The two sides do not need to be dense in order to interact. On an enormous scale, even a very slight pressure can create a boundary. Just as a very faint scent can spread through the air and slowly become diluted until it can no longer be recognized, the solar wind spreads into space until its own signature is weakened by the galactic environment. The difference is that here there is no scent, no air, no human sense to receive it, only instruments measuring particles, magnetic fields, plasma density, and recording each tiny change. A gentler way to see the solar wind is as the sun's way of introducing itself to the galaxy. Every star has its own light, its own mass, its own magnetic activity. The sun is the same. It does not simply sit inside the Milky Way as a point of light. It creates around itself a region of influence. The solar wind is part of that signature. Anything traveling deep within this region is moving through an environment made by the Sunday. Anything that passes beyond the heliopause begins to enter an environment where the shared imprint of the galaxy is clearer than the private imprint of our star. For that reason, the solar wind is not only a phenomenon near the Sunday. It is the thread connecting the center of the solar system to the farthest question about its boundary. There is one point here that is easy to misunderstand. The solar wind is not sunlight. Light is electromagnetic radiation. It travels at the speed of light and takes about 8 minutes to reach Earth. The solar wind is a stream of material particles. It moves much more slowly, usually taking several days to travel from the sun to the region around Earth, depending on the speed of each stream. Light gives us day and night, color, and warmth. The solar wind gives us a plasma environment around the planets, creates interactions with magnetic fields, and helps build the heliosphere. If we only say the sun shines, we understand only half of its presence. The other half is the way it blows matter into space. That difference gives the solar system several layers of influence existing at once. Sunlight can travel very far, so far that even after many years, it continues drifting through space. The sun's gravity reaches out to cold and dark cometary regions. The solar wind has a clearer region of physical control, where its stream of particles pushes against the interstellar medium. When people say Voyager entered interstellar space, that statement is closely tied to this layer of influence. The spacecraft did not suddenly escape every connection to the sun, but it had left the region where the solar wind was the dominant environment. By understanding the solar wind, we understand why an invisible boundary can be measured through data, even though no one can see it with the eye. From the place where Earth is turning, the solar wind may seem distant because it does not touch the skin directly, does not blow through trees, and does not create sounds the ear can hear. But all of modern technological civilization is becoming increasingly aware of its presence. Satellites need protection from particle storms. Astronauts beyond Earth's magnetosphere must account for radiation. Scientists monitor the sun not only out of curiosity, but because the activity of this star can reach the human systems we have placed in space. The invisible is not necessarily unfamiliar. Sometimes it is simply too vast, too thin, and too different from our everyday senses for us to recognize immediately. Perhaps that is why the solar wind is a concept best approached slowly. It does not need to astonish us with explosions or violent images. Its strangeness lies in the fact that a star can quietly fill the region around it with matter that is almost impossible to feel. That stream of material is both extremely thin and extremely powerful on astronomical scales. It creates soft, beautiful auroras in Earth's sky, while also building a gigantic bubble around the planets. It begins in a hot, bright region near the Sun, and ends at a boundary so cold and distant that only a few human-made spacecraft have ever come close to it. Seen this way, each ray of sunlight in everyday life is only one face of the sundae. Behind the light, there are particles. Behind the particles, there are magnetic fields. Behind the magnetic fields, there is a gigantic bubble moving with the star through the Milky Way. The solar wind is the link between the familiar and the distant, from auroras in Earth's sky to the heliopause in the outermost region, from plasma fluctuations near the Sun to Voyager's faint data in interstellar space. It makes the solar system feel less like a collection of separate objects and more like a region with its own climate, blown outward from the center. From that wind that needs no air, a larger image begins to appear. If the Sun continuously blows particles in every direction, if those particles carry magnetic fields with them, like slag continuously blows and then gradually weaken in the distant regions, then around our star there must be something like an invisible dome. Not a hard dome, not a perfect protective wall, but an expanding and moving region of influence, where the solar wind creates the dominant environment. That region is the heliosphere, the Sun's vast bubble in the galactic ocean. To understand the edge of the solar system, we have to travel through that bubble, from the calmer inner layers to the outer shell where the Sun's voice begins to meet the background sound of the stars. A bubble in space does not reveal itself to human eyes. It is not blue the way it appears in illustrations. It does not have a glowing membrane wrapped around the planets, and it does not sit still for a telescope to photograph the way we photograph the rings of Saturn. If seen from far away in ordinary light, the heliosphere almost disappears. The Sun is still bright, the planets still orbit, the background stars remain scattered behind them. But the true region of the Sun's influence, the region created by its particle wind and magnetic field, is hidden in things the eye cannot see. That makes the heliosphere one of the strangest images of the solar system. It is enormous, much larger than the orbits of the familiar planets, but it does not behave like an object. It surrounds Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and even the icy regions beyond. Yet it leaves almost no direct sign in everyday life. We are living inside it, like a small fish that may never recognize the full shape of the water moving around it. To imagine it, the best way is not to draw a perfect sphere. A sphere is too neat. It makes us think the Sun blows wind evenly in all directions, meets the outside environment at the same distance everywhere, and forms a smooth round shell like a soap bubble. Nature is rarely that obedient. The Sun is moving through the Milky Way. The interstellar medium around it also has flow, magnetic fields, and uneven density. The solar wind rises and falls in strength over cycles, sometimes calmer, sometimes more disturbed. All of these factors mean that the Sun's bubble is not a quiet sphere, but a structure that is stretched, compressed, bent, and changed over time. We can think of it as the water around a boat moving across a wide lake. In front, the water is pushed and compressed. Along the sides, the flow slips past the hull. Behind, the wake stretches out and curls back on itself. That image is not exactly the same as the heliosphere, because space is not water, and the solar wind and interstellar medium are plasma, magnetic fields, and energetic particles. But the main feeling is right. Something moving through an environment cannot keep a perfectly round region of influence around itself as if drawn with a compass. It leaves behind the shape of interaction. What makes it more difficult is that human beings cannot place a camera outside the heliosphere and take a full picture of it. Voyager 1 and Voyager 2 have traveled very far, but they are only two tiny points passing through an immense structure. From those 2 points, we know a great deal about the places they have crossed, but we still cannot see the entire outer shell of the bubble. It is like sending 2 small boats into a vast ocean, then using the waves, temperature, and salinity around each boat to infer the shape of the whole sea. The data is precious, but the viewpoint remains narrow. So science has to find another way to map something that cannot be seen, not only by flying very far outward, but also by listening to particles that return from the edge. This is what makes Ibex special. This explorer does not need to travel all the way to the heliopause like Voyager. It stays much closer to Earth, but measures high-energy neutral atoms flying in from the outer boundary of the heliosphere. Those particles are like small letters returning from a distant region, carrying information about the place where the solar wind touches the interstellar medium. The mechanism behind this sounds complex, but it can be felt through a gentler image. In the outermost region, particles from the solar wind meet the extremely thin material between the stars. In those tiny encounters, some particles change state in a way that means they are no longer held tightly by magnetic fields as before. Once they become neutral, they can fly more directly through space, as if they have slipped out of an invisible net. Some of them travel inward through the solar system, where Ibex's instruments can catch them. From their direction and their energy, scientists gradually build a map of a region no human eye can see. A map like that is not like a street map. It has no clear borders, no district names, no sharply drawn roads. It is a map of particle flows, pressure, magnetic fields, and the distribution of energy. The bright and dark regions in the data are not real light, but places where more or fewer particles arrive, where interactions are stronger or weaker. That map is a kind of listening to space through matter. Instead of seeing a wall, we hear where the echo begins to change. From these data, the heliosphere appears as a structure much more dynamic than the simple image of a bubble. It has an inner portion that is more familiar, where the solar wind still fills the environment between the planets. It has an outer layer, where the particle flow begins to slow down and become more turbulent. It has a distant boundary, where the influence of the solar wind can no longer overcome the interstellar medium. The shape of the entire structure is still a subject of research, because different data and different models can emphasize different details. At times, it has been imagined like a comet with a long trailing tail. At other times, newer models have suggested something closer to a two-lobed form, or a shape that has been compressed and bent in more complex ways. That uncertainty does not weaken the story, it makes it more real. The universe does not always hand human beings a complete drawing the first time. Inside that bubble, Earth does not stand at the center. The sun is the source that creates this region, while the planets lie within its flow. Earth is only a small world fairly close to the sun compared with the full size of the heliosphere. That means when we speak of the edge of the solar system, we are speaking of a place so distant that even the distance from Earth to the sun becomes too small a unit to feel in everyday life. Light takes about 8 minutes to travel from the sun to Earth. But to reach the region of the heliopause, light needs many hours, while a spacecraft like Voyager needs many decades. That distance creates a very particular feeling. The heliopause is not near any planet human beings have ever thought of as home. It lies beyond the realm of rocky surfaces, familiar atmospheres, oceans, clouds, or colors that are easy to recognize. There, the sun is only a star brighter than the others, no longer the great fiery disk that dominates the sky. But its wind still leaves a trace. Even when its light has become weak from the perspective of someone standing far away, the stream of particles and magnetic fields that once came from that star is still shaping the surrounding environment. One important role of the heliosphere is to change the way cosmic rays enter the inner solar system. Cosmic rays are high-energy particles that come from outside, many of them created in powerful events in the galaxy, such as the remnants of exploded stars. They are not completely blocked, but the heliosphere reduces and modulates part of that particle flow before it travels deeper into the region near the planets. In other words, the sun's bubble is not an absolute shield, but it is an important environmental layer between Earth and the wider space of the galaxy. It does not make the outside universe disappear. It makes the meeting between inside and outside less direct. This should be understood carefully. The heliosphere is not a perfect protective layer that separates the solar system from the galaxy like a sealed room. Cosmic rays still enter. Neutral material from outside can still slip into the inner regions. The interstellar magnetic field still leaves its influence at the edge. But that very imperfection is what makes the heliosphere interesting. It is not a fortress wall. It is a filtering region, a buffer region, a transition region. It is both open and shielding, both belonging to the sun and being touched by the galaxy from outside. There is a quiet beauty in the thought that Earth lies deep inside such a buffer. Life on the ground is often described through the atmosphere, the oceans, the ozone layer, Earth's magnetic field, and the planet's just right distance from the Sunday. All of those things are important. But if we step farther back, the planet's living environment also lies within a larger layer of context, the region of solar wind surrounding the entire system. Life does not exist in an abstract emptiness. It exists within many layers of protection and interaction, smaller layers nested inside larger ones, familiar layers held within layers that are almost invisible. From here, the solar system begins to feel more like a physical organism than a collection of planets. It has an energy-producing center. It has internal flows. It has an outer layer in contact with a larger environment. It has responses that change with the sun's cycles. When solar activity grows stronger, the particle wind and magnetic fields can make the heliosphere expand or fluctuate in subtle ways. When activity weakens, the pattern of interaction changes as well. We should not imagine the whole bubble pulsing like an obvious rubber ball, but we should not treat it as a frozen object either. It is a dynamic system, slow on the scale of human life, but alive on the scale of plasma and magnetic fields. Because it is dynamic, its outer boundary is not always in the same place. The heliopause can change with solar activity and with the conditions of the surrounding interstellar medium. A spacecraft passing through at one moment may measure a slightly different picture from another spacecraft crossing at a different position at a different time. Voyager 1 and Voyager 2 did not follow the same path, and they did not cross the boundary at the same distance. That matters. It reminds us that the edge of the solar system is not a neat circle around the Sunday. It is a broad surface with shape, asymmetry, and a history of change. The more we think about the heliosphere, the more the question, where does the solar system end, moves away from the language of maps. An ordinary border only needs coordinates. The sun's bubble requires the whole story of the wind source, pressure, magnetic fields, cosmic rays, the interstellar medium, and the motion of the sun through the galaxy. It does not answer with a single number. It asks us to see the solar system as a region of influence being continuously negotiated with the space around it. Inside, everything still carries the feeling of the Sunday light warms the planets. Particle wind fills the spaces between them. The sun's magnetic field stretches outward into broad spiraling lines. Dust and small rocks drift along ancient orbits. Outside, the signature of the galaxy gradually becomes clearer. Cosmic rays play a larger role. Interstellar material becomes the background environment. The external magnetic field is no longer only a minor detail. The heliopause lies where these two ways of belonging meet, belonging to the sun and belonging to the galaxy. No drama needs to be added. The simple truth that human beings have mapped an invisible bubble through particles returning from far away is strange enough. A species living on the surface of a small planet has sent spacecraft outward, placed instruments near Earth, measured particles that almost no one thinks about in daily life, and then rebuilt the rough shape of the cosmic home it lives inside. Not through mythology, but through data. Not through a panoramic photograph, but through patience. That bubble is an important transition between the solar wind and its true outer edge. After we understand that the sun does not only shine but also blows particles, we begin to see that those particles do not dissolve endlessly into the dark. They form a domain. That domain surrounds the planets, redirects part of the high-energy particle flow from the galaxy, and has an outer layer where the pressure begins to change. Deep inside, the solar system still feels like the familiar home of orbits. At its distant shell, it becomes the place of contact between a star and the interstellar ocean. Then, at a distance farther than ordinary intuition can hold, the solar wind begins to lose speed more strongly. The stream of particles that once rushed outward from the corona no longer keeps its original pattern of flow. It is slowed, compressed, and forced to change under the pressure of the outside environment. Before reaching the heliopause, it has to pass through a deeper, more turbulent transition region, where the sun's bubble is no longer as calm as it is inside. From that shell, the story of the solar system's edge begins to become more concrete. Not a sudden stop, but a process of slowing down, becoming disturbed, and giving way. Voyager 2 left Neptune without encountering any boundary. Behind it, the deep blue planet grew smaller in the blackness. The cold bands of cloud, the moon Triton, the faint sunlight falling on a world so distant that it almost no longer belonged to the human feeling of daylight. All of it receded into data, into memory, into precious images sent back to Earth. To a familiar imagination, that scene is easy to see as the final passage of the solar system. The last major planet had been visited. The old list had been completed. The clearly lit part of the map had closed. But the spacecraft kept flying through the realm of the Sunday. The space around it did not change its nature simply because Neptune had been left behind. Its instruments were still recording an environment that carried the trace of the central star. The stream of particles from the sun was still passing through there, far thinner than in the region near Earth, weaker, more diffuse, but not silent. The sun's magnetic field still reached outward in broad spiral lines stretched by the star's rotation. The light had faded into a small source of brightness, but the sun did not lose all its power just because it appeared smaller to the eye. A final planet only ends the easy-to-see part of the story. It has no authority to command the solar wind to stop. That truth makes the old map feel fragile. In that map, the planets stand like great milestones, each with its own name, its own color, its own image. Near the sun are the rocky worlds. Farther out are the giant gas planets, then the cold and slow ice giants. The solar system appears as a chain of objects that can be counted. When that chain ends, intuition wants to place a period. Intuition likes tidy endings. It likes to believe that beyond the last large object lies the outside emptiness. Astronomy has dissolved that period. Neptune is not a wall, and Pluto is not a small gate at the final edge. Those worlds are important because they give us reference points, but they do not hold the essence of the boundary. Beyond Neptune, the solar system does not become a clean emptiness. Beyond Pluto, the sun's influence does not fall away from space like a garment being removed. There are still icy bodies moving in slow orbits. There are still ancient fragments of material, thin regions of dust, stretched out paths, and charged particles passing through the cold darkness. The ending that human beings once placed inside a single name turns out to be only the limit of a map that was too simple. Pluto once held a beautiful role in public memory. It was small, cold, distant, almost made to become a symbol of the farthest place. But when astronomers looked more carefully at the region beyond Neptune, Pluto no longer stood alone at the dark edge. It became a prominent member of a wider icy realm, where many small bodies also orbit the sun along distant, slow paths. The fact that it is no longer the ninth planet in modern classification does not make it lose its strangeness. On the contrary, it reveals a more fascinating truth. The place once imagined as an ending is actually a doorway into a region quietly crowded in its own way. The objects in that outer region are not as loud as the great planets. They do not dominate the sky with size, do not have giant storms that are easy to see, do not have brilliant rings that immediately seize the imagination. They are smaller, darker, colder. Many appear only as faint points of light in a telescope. But that modesty is exactly what preserves part of the solar system's ancient memory. Near the star, material has been heated, collided, transformed, and rearranged over billions of years. In the colder regions, some fragments of ice and rock may preserve traces of the earliest time when the planets had not yet become as complete as they are today. The outer edge, then, is not a meaningless leftover of the map. It is more like an extremely cold archive of a long history. Even so, that icy region is still not where the sun's breath ends. The solar wind continues through space beyond the planets, like a very thin current that needs no air. It does not care which object human beings call a planet, which one a dwarf planet, and which one belongs to an icy belt. It simply keeps moving according to its own physical conditions, spreading outward, becoming thinner, carrying magnetic fields with it, responding to changes on the sun, and then advancing into the region where the medium between the stars gains a stronger and stronger voice. Names help human beings arrange the world. Particles do not fly according to names. One thing is very easy to overlook. The edge of a star system does not necessarily lie at the last object that is easy to see. A flame does not end where our eyes stop seeing the clearest yellow color. Its heat still spreads a little farther. Its smoke still drifts for a while. Its scent still lingers in the air after the flame has grown small. The sun also leaves behind many different layers of influence. Its light weakens with distance. Its warmth nearly disappears in the outer regions. Its particle wind continues farther still. Its gravity holds objects at distances for which human life has almost no emotional scale. So to speak of the solar system's edge through a single object is like trying to describe the entire ocean by the last stone visible on the shore. The old way of seeing makes the solar system feel like a row of rooms. Step through the room of Jupiter, then the room of Saturn, then Uranus, Neptune, and after that, the exit. The truer view is more like a domain of influence gradually fading. Near the center, the sun overwhelms everything with light and energy. Farther out, the large planets still appear as powerful worlds, but between them are already immense stretches of empty space. Beyond the planets, large objects become sparse. Darkness takes up more, and the signs become harder to see. In the end, things without clear shapes, particle pressure, plasma density, magnetic fields, cosmic rays begin to matter more than named spheres. It is this shift from objects to environment that makes the outer region worth listening to. If we only wait for a new planet to appear, the space beyond Neptune may seem poor. But if we listen to the flow of particles and magnetic fields, it becomes the region where the power of the sun is tested little by little. In the inner region, the sun is like the main storyteller. Its wind creates the background of interplanetary space. Its magnetic field extends and coils outward. Eruptions from the star can carry their influence to the planets. The farther outward we travel, the softer that narrative voice becomes, while the background sound of the galaxy begins to grow clearer. High-energy cosmic rays, extremely thin interstellar material, magnetic fields that do not belong only to the Sunday. Space does not change color to announce this. It does not build a glowing dome at the end of the planetary region. The change lies in the data, in the way particles arrive in smaller or larger numbers, in the speed of the plasma flow, in the turbulence of the magnetic field, in the way a spacecraft like Voyager gradually begins to hear an environment different from before. An icy world can give us an image. A physical boundary gives us traces. Images are easier to love, but traces are what carry us into the deeper part of the story. At this point, the planets are like prominent words on a page, while the spaces between them are the quiet grammar that makes the whole sentence meaningful. If we read only the large words, we know the names of the main characters. But the grammar of the solar system lies in gravity, particle flows, magnetic fields, light, dust, and transition regions. Neptune is a very beautiful word. Pluto is a word once misunderstood, and then understood again in a richer way. But the sentence does not end there. After those words, nature's punctuation has still not appeared. There is only ink fading thinner, wider blank space, and smaller symbols that require a more patient way of reading. Voyager 2, after Neptune, is a fitting image for that change. Before then, it had been the messenger carrying images of the planets, bands of cloud, rings, moons, unfamiliar surfaces. Afterward, it became an instrument listening to the environment. There were no longer many new scenes to send back, but its value did not diminish. It was moving through the place where the map of images becomes poorer, while the map of particles becomes richer. An exploration can lose color and gain depth. The edge of the solar system belongs to that kind of exploration. The wind from the sun does not read human maps. It does not know that Neptune is the last planet of the main planetary system, does not know that Pluto once sat at the end of old diagrams, and does not know that the distant icy region beyond has forced human beings to revise the way they name things. It simply continues outward, carrying charged particles, twisted magnetic fields, and small disturbances born from a star still ceaselessly active at the center. Past the planets, past cold orbits, past wider and wider stretches of emptiness. That wind grows thinner but does not vanish. Then, in a very distant realm, where no large planet waits, where no surface shines, it meets the thing that truly changes it, the quiet pressure of the space between the stars. That change is not like the collision of two solid objects. There is no wall rising in the darkness for the particle stream to strike. There is no pane of glass against which the solar wind breaks apart. Everything happens in an environment too thin for human senses to call matter in the ordinary way. But on the scale of the solar system, that thinness is still real enough. Interstellar material, external magnetic fields, and high-energy particles create a background pressure. The solar wind, when it is still near its source, is stronger and faster. The farther it spreads, the more it has to divide its strength across an enormous sphere, the thinner it becomes, and eventually it can no longer continue, as if everything ahead belongs entirely to it. The place where the wind begins to slow down sharply is called the termination shock. The word shock can make people think of an explosion or a violent scene, but here it is a physical concept, a region of more sudden transition in the plasma flow, where the solar wind changes from a very fast state into a slower, hotter, more compressed one. It is like the moment when a river rushing strongly outward suddenly meets a very different kind of resistance in deeper water. The surface may churn, the direction of flow may shift, and energy is redistributed. In space, there is no water surface, but there are particles, magnetic fields, pressure, and waves moving through plasma. The wind does not stop, but it is no longer the same wind. What matters is that before this region, the solar wind moves faster than disturbances can travel back through its own plasma environment. Said more gently, it rushes outward too quickly for the region ahead to send information back in the usual way. When it meets the growing pressure of the outside environment, the adjustment does not happen as smoothly as a gradual slowing down on a wide road. It occurs through a strong transition zone where the particle stream is compressed, heated, and changed in state. The solar wind is still the solar wind, but it has crossed from a confident flow into a more disturbed region, where the galaxy begins to place a hand on its shoulder. No one sees the termination shock the way one might see a bright line through a telescope. Voyager recognized it through changes in the environment around the spacecraft. When Voyager 1 crossed this region, scientists did not receive a photograph they could hang up and say, "This is the boundary." Instead, they received data about energetic particles, magnetic fields, the speed of the solar wind, and signs that the spacecraft had entered the more turbulent outer layer of the heliosphere. Voyager 2 later crossed the same kind of boundary in a different direction, at a different time, and did not encounter it at exactly the same distance. That detail is worth noticing because it dissolves yet another illusion. The sun's bubble is not a neat, beautiful sphere. That unevenness fits the nature of everything described before. The sun does not blow out a perfectly identical wind at all times. Its activity changes in cycles. Regions on its surface and in its corona are not all the same. Large eruptions can send stronger waves of plasma into space. Outside, the interstellar medium is not a perfect, flat, uniform background either. When two changing systems meet, the boundary between them cannot be a static circle. It can be pressed in on one side, stretched on another, shifted over time, and made to respond to stronger or weaker waves of wind from the Sunday. A spacecraft passing through in one direction touches only one sentence in that enormous book. Inside the termination shock, the solar wind still seems to retain its original character. It moves outward quickly, grows thinner with distance, and carries the sun's magnetic field with it. After crossing this transition region, that flow becomes slower and more stirred up. The particles no longer simply rush outward through a relatively familiar background. They are compressed, their energy changes, and they become mixed with more complex disturbances and structures. Some of the energy turns into heat, density, and pressure shift. The magnetic field can become stronger in the compressed region. Space is still silent in the sense that no sound travels to human ears, but physically, it has become much noisier. We can think of the termination shock as the place where the sun begins to speak more slowly. In the inner region, its voice is clear and fast, pouring past the planets through a continuous stream of particles. In the outer region, that voice does not disappear, but it becomes stretched, roughened, and blended with the background sound of the interstellar medium. This way of speaking does not replace the physics, but it preserves the real feeling. A current of influence has traveled too far from its source and has begun to meet something larger. The sun does not lose there all at once. It simply no longer decides the conditions of space alone. The existence of the termination shock also shows why the edge of the solar system has many layers. The heliopause is often mentioned as the boundary where the solar wind is no longer strong enough to push back against the interstellar medium. But before reaching that place, the solar wind has already gone through an important transformation. It does not move from a free state to a stopped state in a single step. It slows down, heats up, becomes compressed, and then enters a wider, more disturbed outer shell. That region is the heliosheath, where the wind has been reshaped but has not yet completely yielded to interstellar space. So the ending of the sun's breath is not a clean cut, but a sequence of changes. When we look closely at that sequence, we see that the universe has a way of softening even concepts that seem sharp. Inside and outside are not always separated by a hard wall. A flow can still belong to its source, but already be deformed by the outside environment. A region of space can still lie within the sun's bubble, while already carrying the signs of contact with the galaxy. A spacecraft may not yet have entered true interstellar space, but it may have already left the region of fast and relatively intact solar wind. These intermediate states make the story less tidy, but richer. Voyager crossing the termination shock is like a tiny needle passing through a sheet of fabric stretched to hold the forces. Behind it is the pressure from the Sunday. Ahead is the pressure from the medium between the stars. The needle cannot see the whole fabric, but it can sense the changing tension as it passes through. Each measurement is a small touch against a much larger structure. From those touches, scientists reconstruct an image of where the wind slows down, where the outer shell begins, and where the sun's bubble is no longer as calm as it is in the regions near the planets. One thing is very easy to lose if this story is told too quickly. The termination shock is not the final edge. It is the first major hesitation of the solar wind on its outward journey. The wind continues after that, but it has changed. It has entered a region that is denser in terms of interaction, where particles and magnetic fields are more strongly stirred, and where information from the sun and information from the galaxy begin to mix more deeply. One might imagine it as a zone of breaking waves far from shore, but there should be no thought of a sandy beach there. There is only plasma-changing state, in a darkness too vast for any everyday image to hold completely. That slowing has its own beauty. Before it, the sun still seems to be extending itself through its stream of particles. After it, The sun's breath begins to carry the trace of an encounter. A star does not need to touch anything solid to know it is not alone. It only needs to blow far enough. Out there, where the light has weakened, where the great planets are only a memory far back inside, the interstellar medium begins to answer with its pressure. That answer is not loud, not fast, not visible, but it is enough to change the speed and temperature of the wind from the Sunday. When we think of such a major slowing down, it is easy to imagine a complete stop. But the solar wind does not stop at the termination shock. It passes through, like a stream of traffic slowing down to enter a rougher road, no longer as steady as it was on the highway, but still continuing outward. In the region beyond, everything becomes more complex. Particles may change direction more often. Magnetic fields are twisted and compressed. Disturbances from the sun, if they are strong enough, can still travel very far and make the outer region tremble in ways instruments can detect. The edge of the solar system, instead of being a fixed border, is more like a slow weather zone of plasma. From Earth, almost none of this can be felt. A person looking up at the sky does not see the termination shock. An ordinary optical telescope cannot photograph it as a bright line around the solar system. But that invisibility does not make it any less real. Many important structures in the universe exist by acting on other things. Gravity appears through orbits, magnetic fields appear through charged particles, plasma appears through signals and fluctuations. The termination shock is the same. It does not need to have a shape for human eyes. It lets the wind change its nature, and then lets spacecraft report that change back through data. Perhaps the strangest part is that this region belongs to an ending, yet is still very far from the final end. It is like the moment when a voice begins to grow hoarse, even though the speaker has not gone silent. Like water changing color before it fully empties into the sea. Like a region of light fading before we can truly call it darkness. The solar wind beyond the termination shock still comes from the sun, but it can no longer keep its original wholeness. That breath has met the climate of the galaxy, and the encounter has made it heavier, slower, and more tangled. Out in that distant region, the sun is no longer the dominant bright disk it is in Earth's sky. It is a small star, but it still has its own physical voice. That voice is carried by particles and magnetic fields, traveling across a distance human beings can only understand through astronomical units, through the years of flight of a space probe, through faint signals that take many hours to return. When that voice stumbles into the medium between the stars, the solar system appears not as a house with walls, but as a region of influence, being slowed at its edge. The wind is still moving, but ahead of it is no longer a space that belongs only to the Sunday ensign. Ahead lies the broad, disturbed outer shell, where the breath of the star continues to drift in a changed state. After the giant planets, Voyager no longer had many scenes to send home. There was no longer a gigantic disk of clouds like Jupiter, no thin, bright rings like Saturn, no distant cold blue of Neptune drifting through the lens like a final period in the dream of planets. Ahead of the spacecraft was not a new world waiting to be photographed, but a dark realm so vast that images began to grow poor. To human eyes, that place offered almost no stage. No mountains, no seas, no clouds, no surface, no horizon. Only space so thin it is difficult to imagine. Sunlight weakened by immense distance, and particles so small that the whole story had to be heard through instruments rather than seen by the eye. But in the place with the fewest images, the solar system began to reveal one of its truest parts. The wind that had once left the sun had slowed down. It no longer rushed outward in its old form. The charged particles still came from the central star, still carried the sun's magnetic field with them, but they had entered a region very different from the calmer inner realm. Everything became compressed, stirred, heated, and mixed with fluctuations arriving from many directions. If the planets are the face of the solar system, then this region is the faceless part, harder to draw, less striking, but deeply revealing about how our star touches the galaxy. The scientific name for this region is the heliosheath. We can hold that name lightly in the mind, like the name of a soft, tangled shell around the sun's bubble. It is not a hard shell. It is not like an eggshell, not like a wall of glass, and not like the evenly stretched skin of a balloon. It is a region of plasma that has changed its character, lying beyond the place where the solar wind is strongly slowed, and before the farther boundary where the interstellar medium truly takes the leading role. Inside it, the sun is still present, but no longer present with a clear voice. Its voice has been stretched across distance, roughened by outside pressure, and blended with the extremely faint background of the Milky Way. A region like this is easy to misrepresent if we only call it the space between. The space between can sound temporary, like a hallway connecting two more important rooms. But the heliosheath is not an empty corridor. It is more like the swirling water where a great river has slowed before joining the sea. The water there still comes from the river, but its color, speed, and motion have changed. It is no longer the confident straight current from upstream. It is not yet the open ocean. It is a mixing region, a wavering region, a place where everything both keeps its old origin and is touched by a new environment. In space, that mixing has no muddy color like river water meeting seawater. It appears through particles and fields. Part of the plasma flow from the sun slows after being compressed. Magnetic fields are bent and dragged along with the disturbed motion. High-energy particles entering from outside begin to leave a clearer trace. Disturbances born from the sun long before can travel to that distant region like a delayed wave, making the shell tremble in the data. There is no true sound traveling through a vacuum, but if the measurements could be transformed into something audible, this region would probably not sound like absolute silence. It would be more like a very low, uneven background tone, as if a breath were mixed with the wind of some farther place. Voyager passed through that region with the particular solitude of an aging machine. It had already finished the part the public most easily remembers. The planetary encounters, the photographs, the discoveries with clear shapes. Then it continued living in a less glamorous role. There were no longer images that could make the whole world immediately recognize a new world, but every change in particle counts, every signal from the magnetic field, every piece of cosmic ray data became more valuable. The spacecraft no longer told its story through great images. It told it through the changing character of the environment around it. There is a faint sadness in this kind of exploration. Not a tragic sadness, but the feeling of a journey that has passed through its brightest realm and entered a place where everything must be read more slowly. Near the planets, science can bring back photographs, a giant red spot, an icy ring, a cracked moon, an unfamiliar surface. In the heliosheath, science brings back signs that are harder to see. One particle flow decreases, another increases. A field tilts. A plasma environment no longer resembles what came before. The wonder has not disappeared. It has simply left the eye and entered patience. That tangled shell also makes the idea of protection less simple. The sun's bubble is often imagined as a region that softens part of the cosmic ray flow from the galaxy. But it is not a perfect shield. It does not lock the solar system inside a sealed room. Cosmic rays still enter. Neutral material from outside can still slip through. The interstellar medium still touches the outer layer with its pressure and magnetic field. Protection here does not mean absolute blocking. It means deflecting, slowing, mixing, and altering the paths of particles. The heliosphere is more like a weather region than a wall, and the heliosheath is where that weather becomes most complex. This makes the solar system feel less like a mechanical model. It does not only have the sun in the middle and planets moving evenly around it. It has a more familiar inner region, a particle wind flowing outward, a disturbed outer layer, and a distant boundary where pressure from both sides comes into balance. It feels more like an enormous physical body, with a source of energy, internal flows, a shell, and contact with the surrounding environment. There is no will, no purpose, but there is structure. There is no emotion, but there is a rhythm of change. There is no voice, but there are traces to read. In the inner region, the sun almost imposes its language on space. The light is stronger, the particle flow clearer, the large planets embedded in the environment it creates. In the heliosheath, that language begins to be mistranslated by the galaxy. The sun's trace is still there, but it is no longer clean. The trace of the outside has not fully taken over, but it has entered every measurement. One particle may carry the story of the Sunday, another may come from a more distant region of the galaxy. Both move through a realm with no scene to look at, yet full of signs of contact. That contact is not violent in the way human beings usually imagine violence. It is not two storms crashing together in an explosion. It is a meeting of things that are extremely thin, extremely wide, and extremely patient. Plasma from the sun has traveled billions of kilometers. Interstellar material lies scattered between the stars, thinner than any air we have ever known. Magnetic fields stretch across distances that are difficult to imagine. Cosmic rays come from faraway events in the galaxy. All of them meet in a region where the eye sees almost nothing. Sometimes, the universe places its greatest encounters in the places that look the emptiest. Perhaps that is why the heliosheath carries its own feeling when it is told correctly. It is not fascinating because it is beautiful in the way a planet is beautiful. It is fascinating because it is where the solar system begins to lose certainty about itself. In the inner region, everything is easier to call the sun's. In this outer region, the word belonging becomes softer. The particle flow still belongs to the sun, but it has been reshaped by the outside environment. The space still lies within the heliosphere, but it is already full of the interstellar background. The boundary has not yet arrived, but the feeling of the edge has already begun to seep into every measurement. If Voyager could have memory, this region would be the least colorful but most meaningful part of its journey. After the brilliant encounters with the planets, it entered a place with no large object left to gaze upon. But instead of running out of story, it began to hear the structure of the home in which the planets reside. It did not need to see that shell in order to touch it. Each day it traveled farther from the sun. The spacecraft moved through an environment rewritten by outside pressure. The particles striking its instruments were the way the edge of the solar system introduced itself. In this shell, distance is not only a matter of near or far. Distance becomes a change in character. Farther means the wind has grown more tired. Farther means the outside pressure has a clearer opportunity to act. Farther means the data no longer carries only the voice of the Sunday. This kind of far is not a number to read and forget, but a state. The farther a place is, the fewer images there are to hold on to, and the more things must be understood through small changes. The heliosheath is the region where distance becomes the character of space. The darkness there does not belong entirely to darkness. It contains the remnant of the sun's breath, slowed particles, bent magnetic fields, and the first clearer signs of the interstellar medium. It is like a page written by two different hands, one line pressing over another, not so much that it becomes unreadable, but enough that the reader must be patient. The sun writes with its plasma. The galaxy writes with cosmic rays, thin gas, and external magnetic fields. The heliosheath is the region where the writing overlaps. What makes that region memorable is not that it gives a tidy answer. It does not say, the solar system ends here. It says something more delicate. The ending is being prepared through mixing. Before one current of influence gives way, it becomes more tangled. Before another environment takes priority, the two environments coexist in an unsettled state. Before the farthest boundary of the solar wind bubble, there is a wide shell where everything is already different, but has not yet fully changed ownership. At the far end of that tangled realm, the sun's breath continues to weaken. It no longer has the form of the fast wind of the inner region, no longer has the clarity of planetary orbits, no longer offers a great scene for the human eye to recognize. Only particles, force fields, and very thin pressures remain, searching for equilibrium. The sun is still present in every sign, but the galaxy is now very close within the same environment. Between those two sides, the true boundary does not need to appear as a line of light. It only needs to let the measurements show that a star has blown so far that it has finally met the rest of space. On Earth, the giant antennas did not receive any declaration from the edge of the solar system. They received a very weak stream of signals, traveling across billions of kilometers before touching the ground, then being separated into small numbers about particles, plasma, and force fields around Voyager. Outside the control room, life went on as usual. Cities still glowed with lights. Oceans still rose and fell. Clouds still drifted across continents. But within those thin lines of data, there was a change large enough to widen humanity's cosmic map. The spacecraft had reached the place where the particle wind of the central star no longer wrapped around it as before. That moment did not resemble a departure the human eye could recognize. Voyager did not see a shoreline receding behind it, did not pass through a new landscape, did not photograph a bright streak marking the place of transition. It still received light from the old source, still felt the faint pull of the star that had kept the planets in orbit, still sent signals back to a blue planet lying deep inside the inner region. But the material around the spacecraft had changed. The particles that once carried the voice of the solar wind had clearly thinned. High-energy particles from the galaxy had become more prominent. The surrounding plasma no longer resembled the extremely thin layer inside the star's bubble. Space had not turned into a different scene, but it had changed the way it touched the spacecraft. That boundary is called the heliopause. The name may sound cold, but its nature is not lifeless at all. It is the place where a region of influence reaches its limit, where the thin stream of material from the star has traveled so far that it can no longer push the interstellar medium outward as easily as before. From inside, charged particles and magnetic fields have made a journey of immense distance, past the planets, past the dark icy region, past the tangled shell where the wind was slowed. From outside, the thin gas between the stars, extremely fine dust, the local magnetic field, and cosmic rays place a small but lasting pressure on that bubble. The two sides hold each other through things that are almost invisible, and it is that mutual holding that creates the soft edge of the solar system in the sense of particle wind. It is not the edge of everything. Light continues farther. Gravity extends the story into colder and wider realms beyond. Objects in the distant region, especially the comet nuclei thought to belong to the Oort cloud, still make the phrase, leaving the solar system more layered. But if we are speaking of the cosmic climate created by the solar wind, the heliopause is a very real threshold. Inside it, space still carries the main background of the particle stream from the star. Outside it, the material between the stars takes on a clearer role. Voyager did not leave every connection to the old source of light. It left the way that source had enclosed it in plasma. This distinction gives the outer edge a very human feeling, even though the entire phenomenon is completely physical. A person can travel so far from home that the air, the voices, and the surrounding light all become different, while memory remains, names remain, and origin remains. Voyager carries a kind of origin as well. It was created on a planet orbiting that star, used the gravity of the giant planets to gain speed, carried the technical imprint of an older era, and then drifted into a region where the background around it no longer belonged mainly to the place where it was born. There is no sadness there in the human sense, but there is a very quiet feeling. A small piece of the inner region has traveled far enough to hear the galactic background more clearly than the background of its old home. Voyager 1 crossed that threshold in 2012 after many decades of outward flight. The confirmation did not come from a single glance. Scientists had to bring together many signs: the sharp decrease in lower energy particles connected with the inner heliosphere, the increase in galactic cosmic rays, and then plasma oscillations showing that the outside environment was denser than the extremely thin region inside. The data did not always behave exactly according to the simple initial picture, So the conclusion required caution. That caution is what makes the moment more trustworthy. An invisible boundary is not recognized through inspiration, but through many pieces of evidence slowly leaning in the same direction. Voyager 2 crossed the heliopause in 2018, along a different path and at a different time. It helped humanity understand that the outer edge of the sun's bubble is not a clean circle placed evenly around the star. The particle wind changes with the sun's activity cycle. The surrounding interstellar medium also has its own magnetic field and flow. So this boundary can be uneven, wrinkled, shifting, and responsive to disturbances from within and pressure from outside. A star drifting through the Milky Way does not carry a perfect shell with it. It carries a living region of influence, thin at the edge, sensitive to each change on both sides. What makes the heliopause different from beautiful scenes in astronomy is that it does not try to overwhelm the observer with an image. Saturn can hold the eye with its rings. Jupiter can hold the eye with its cloud bands and great storm. Nebulae can appear as layers of color in deep images. But this place holds the imagination through a change in background. Before it, Voyager was swimming in the climate of its star. After it, it was drifting in the more general material of the stars. The change does not need color to have weight. It is like the moment of stepping beyond the resonance of a large room. The wall does not appear before the eyes, but the sound around the body has changed. At the heliopause, the thinnest things create the largest structure. A single particle is almost negligible. A magnetic field cannot be seen with the eye. A trace of interstellar gas is too thin to form any familiar image. But on the scale of the solar system, these elements add up into an enormous balance. The particle wind pushes outward. The interstellar background presses inward. Neither side needs to be dense, only persistent. The boundary, therefore, does not arise from solid matter, but from the relationship between two environments. The universe can build an edge out of almost nothing, as long as that almost nothing extends far enough. There, too, the idea of protection becomes softer. The heliosphere bubble is not a sealed shield, but it changes the way high-energy particles from the galaxy enter the inner region. It deflects, slows, mixes, and reduces part of the outside environment's effect. Earth lies deep inside many such layers: the atmosphere, the planet's magnetic field, its distance from the star, and the vast region of particle winds surrounding the system. The heliopause is the outer edge of one of those layers, imperfect but real, quiet but involved in the cosmic conditions in which the planets live. From very far away, Voyager becomes a test of the word home. Home is not only a place with ground beneath your feet. For a planet, home is a stable orbit, enough light, a magnetic field, an atmosphere, and a source of energy. For the entire solar system, home is also a vast plasma region, where the central star blows out its own kind of climate as it swims through the galaxy. When the spacecraft crossed the heliopause, it did not erase the home behind it. It only showed that this roof has a place where it grows thin, a region where the private nature of the star becomes part of the common space between the stars. There is no need to call that moment lonely. Loneliness is too small and too human a word for a plasma environment so vast that even light needs many hours to cross it. The more fitting feeling is the quiet of being joined to something larger. Inside the heliopause, the solar system keeps a private region within the Milky Way. Outside it, that private region blends into the shared background, where matter once cooked inside older generations of stars, spread out, cooled, mixed, and continued on as material for later worlds. A boundary like this does not divide completely. It reminds us that every star has its own domain, but no star is ever truly separate from the galaxy that gave birth to it. Voyager's signal, then, is not only proof of a distant flight, it is a way for human beings to touch the invisible shape of the place where we live. From the ground, we watch the sun rise and set, thinking of it as the source of daylight. From the edge of the heliosphere, that source of light appears differently, not only as a bright point against the dark, but as the center of a region of influence that has reached very far and then thinned before a wider environment. The ending there is not like a period, it is more like ink fading until it blends into the color of the page. Voyager continues to send back faint pieces of news, each one taking a very long time to return to Earth. Within those signals is a gentle paradox. The farther the spacecraft moves from the star's enclosure, the more clearly it helps human beings understand how wide that enclosure once was. It has left the main layer of particle wind, but that is precisely what allows the heliosphere to take shape in the imagination. Something invisible around the planets needs an object to leave it before we can realize it has an edge. In that place, the silence no longer belongs only to the Sunday. It carries the background of the stars. Behind Voyager, the old source of light has not gone out. Ahead and all around it, interstellar space opens not as meaningless emptiness, but as the vast material that every star system must meet. The solar system does not vanish at the heliopause. It simply stops wrapping the spacecraft in the wind that followed it through most of its journey. And in that almost shapeless change, the edge of our cosmic home becomes more real than any outline human beings could draw. After Voyager passed the place where the particle wind of its mother star grew thin, the first thing waiting for it was not a cleaner emptiness. The darkness there may seem wider. The familiar light had become smaller behind it, and the planets that had once been the great milestones of its journey now belonged only to the memory of data. But what surrounded the spacecraft was not nothingness. It was a layer of matter so sparse that it almost had no shape, a very old sea of the galaxy, where atoms, dust grains, magnetic fields, and high-energy rays had drifted through stories much older than Earth. The name interstellar medium may sound cold and distant, like a term placed between lines in a textbook. But heard more slowly, it has an almost quiet depth. It is the material that lies between the stars, not dense enough to become clouds like those in Earth's sky, not bright enough for human eyes to call it scenery, and not empty enough to be treated as nothing at all. It is the thin background through which star systems are swimming. A star can blow a private region around itself, as the Sun has done with the heliosphere, but that private region always lies within a larger substance. Voyager had just touched that substance. Where the spacecraft is traveling, a cubic centimeter of space may contain only a few particles, sometimes fewer, depending on the region. Compared with the air on Earth, that number is almost unimaginable. On the ground, every breath contains so many molecules crowded together that our bodies never have to think about emptiness. Between the stars, matter is as sparse as dots scattered across a page without an edge. But that page stretches across light years, through gas clouds, through the remnants of dead stars, through regions where new stars may be born. When the distance is large enough, even sparseness becomes a real force. An interstellar dust grain is too small to form an image in the mind. It may be only a very fine piece of carbon, silicate, ice, or simple compounds, drifting through cold and darkness. But across long distances, countless grains like this make starlight dimmer, shift its color, and leave a thin filter over the picture of the galaxy. Astronomers read dust by seeing how it blocks, reddens, or scatters the light behind it. So the almost unseen helps decide how we see the universe. Beyond the heliopause, Voyager is not flying through an empty stage. It is flying through the kind of material that has been quietly writing on light for a very long time. The gas there is mostly hydrogen and helium, the lightest, oldest, simplest elements in the universe. Mixed among them are small amounts of heavier elements, elements that were not produced in great abundance at the beginning, but were made inside stars during the lives and deaths of stars. Carbon, oxygen, silicon, iron, and many other ingredients were once cooked in ancient nuclear furnaces, then blown outward when aging stars lost their outer layers or when some stars ended in powerful explosions. The galaxy does not throw away what stars have made. It mixes those materials into the darkness so that later they can take part in new generations of stars, new planets, new rocks, new water, and eventually bodies that can look up at the sky. So the region outside the sun's bubble is not only outside, it is the shared part of a much larger cycle. Matter that once lived inside stars returns to the space between stars. Some of it cools and gathers into cold clouds. Under gravity, those clouds can contract and give birth to new stars. Around new stars, disks of dust and gas may create planets. One day, on a planet quiet enough, that matter may become oceans, minerals, atmospheres, cells, eyes, and memory. When Voyager enters interstellar material, it is not entering a completely alien place. It is entering the old storehouse of the ingredients that the solar system itself once needed in order to be born. That thought makes the outer edge feel less cold. Behind Voyager is a star nourishing its planets with light and gravity. Around it is the larger material that, in a deeper sense, once nourished that star itself. The sun did not appear from nothing. It formed from a cloud of gas and dust in the galaxy more than 4 billion years ago. The atoms that make Earth, rock, water, and living bodies do not belong only to a local story. They belong to the long history of the interstellar medium. Beyond the heliopause, the spacecraft is touching the kind of background in which our own material ancestors once drifted. In that region, magnetic fields are also present like a colorless stroke of ink. They do not form bright lines, do not appear as taut threads stretched between the stars, but they influence the way charged particles move. Cosmic rays, very high-energy particles from powerful events in the galaxy, also travel through there. While Voyager was still inside the heliosphere, the particle wind of its mother star changed the paths and intensity of some of those particles. After crossing the edge, this background became clearer. Not as real sound, but as rises and falls in the data, as the instruments recorded that the spacecraft was now inside a different substance. The subtle point is that this substance is not standing still. The solar system is moving through a local region of the interstellar medium, often imagined as a very thin cloud surrounding our neighborhood in the Milky Way. Beyond it are other regions, denser, thinner, hotter, colder, more ionized, or richer in dust. The galaxy is not a flat background. It has its own climate, if we use the word climate in the broadest sense, regions with different properties, flows, darkness that contains matter, old remnants, places where stars are being born, and places where stars have died. In that context, the heliosphere is like a private chamber drifting through an old sea. Its shape depends on the particle wind inside, but also on the material outside. If the surrounding sea changes direction or pressure, the private chamber is reshaped as well. If the mother star becomes more active, the region of influence may respond. The edge Voyager crossed does not stand outside all history. It is where two histories meet. One is the younger history of the solar system, with its planets and the wind from its central star. The other is the older history of the galaxy, with gas, dust, force fields, and particles arriving from far away. There is a very different way to hear Voyager when we think of it there. It is not only a small machine flying far away. It is an organized piece of matter, assembled by human beings from metal, wires, circuits, plutonium, glass, antennas, and the intention to explore. The atoms in its body also have a cosmic history. The iron, aluminum, copper, and silicon in its parts are not private gifts from Earth. They come from the long story of earlier stars, gathered into the solar system, into the planet, into ore, into technology, and then launched back out into the space between stars. A portion of the old interstellar medium, after billions of years, learned how to make a spacecraft so it could return to the old sea and measure it. There is a beauty in that which is difficult to fully express. The universe creates matter. Matter creates stars. Stars create heavy elements. Those elements create planets. Planets create life. Life creates curiosity and machines. Machines leave the planet to measure the region of matter that once took part in that long chain. Voyager is not a complete stranger among the stars. It is material from the galaxy, arranged into a question, then sent back into the galaxy in the form of a very small machine. Outside the sun's bubble, the immensity does not have to make the listener feel empty. It can make us feel connected to an older current. Each gas particle drifting through that region may never touch the spacecraft. Each dust grain may pass through the darkness along very long paths, but together, they form the background of a galaxy recycling itself. Cold clouds of gas can collapse into stars. New stars can light up dark regions. Aging stars return matter to the space between. The emptiness between the stars turns out to be a pause in a cycle, not the absence of a story. This also changes the solar system when we look back at it. Inside, we can love the planets as separate worlds: blue Earth, red Mars, giant Jupiter, Saturn with its rings, icy moons, and distant outer regions. From outside, all of it appears as a small bright domain blown outward by one star in a larger sea of matter. That bubble has value because it is its own, but it is not separate from the shared whole. It is like a lamp set inside thin mist. The light creates its own halo, but the mist is still the mist of the entire field. Voyager is now where that private halo has receded. Its signals do not make the interstellar medium familiar in an everyday sense, but they make it less vague. There is density to measure. There are particles to count. There are plasma oscillations to infer. There are cosmic rays to compare. Something that once seemed only like the dark background between science does not need to make the universe less mysterious by explaining everything. Sometimes it deepens the mystery. General dangers, the dark spaces have structure, history, and a voice of their own. In that region, the meaning of outside becomes softer. Outside is no longer the part after the solar system's story ends. It is the part that has always surrounded that story. It presses against the heliosphere, sets limits on the particle wind, sends cosmic rays into the inner region, and provides the material background from which the mother star itself was once born. An ending is not separate from a beginning. The edge of the solar system is where the present breath of the star meets again the older sea of matter that once allowed that star to form. Seen this way, the distance of the interstellar medium is no longer only distance. It becomes depth of time. The particles out there may have drifted through very long processes before coming near the edge of the heliosphere. Some atoms may once have been inside star-forming regions. Some dust grains may carry traces of aging stars. Some cosmic rays may come from explosions that happened before human beings knew how to write, before Earth had the familiar landscapes we know today, even before many complex forms of life appeared. The space between the stars is distance, but it is also memory. That memory does not speak in words. It speaks through chemical composition, through light dimmed by dust, through the paths of charged particles in magnetic fields, through the way gas clouds give birth to new stars. Voyager, small and persistent, touches only a very narrow slice of it, but even one slice is enough to change the human feeling of the outer edge. Beyond the heliopause, no empty black curtain opens. An older, wider environment is there, less familiar but not completely alien, quiet as a sea before it has a name. In that sea, the solar system still matters. It does not dissolve into nothing. It remains the domain of a star, with planets, orbits, icy regions, exploring spacecraft, and a small planet reading signals from very far away. But beyond the edge of the particle wind, the system's story is placed inside a larger frame. The sun is no longer only our center. It becomes a star moving through the shared material of the galaxy, carrying a thin bubble, a family of planets, and a living species that has learned to ask where the private meets the common. Voyager continues to drift through that background, not heading toward any nearby star on a timescale human beings can wait for, not becoming an interstellar ship in the fast dream of science fiction. It moves slowly, steadily, and almost silently. But the simple fact that it is now inside the local interstellar material is enough to make the darkness beyond the solar system feel more real. Beyond the edge, there is not absence. Beyond it is the old sea, where the matter of the galaxy rests, drifts, mixes, and prepares for births very far in the future. There, our home is not lost. It is placed properly inside its larger sea. Inside is the familiar bright region of a star. Outside is the ancient material that once helped give birth to stars. Between the two, there is no sharp cut, only the gradual transition of origin, particles, force fields, and background noise in the data. The edge of the solar system, then, is not where the story ends. It is where the private story of the Sun touches the very long story of the Milky Way. Far beyond the particle wind of the central star, there are objects that do almost nothing for most of their lives. They do not shine, do not have brilliant atmospheres, do not leave long tails across the sky, and do not pass near the planets where human beings can easily notice them. They lie in cold and darkness, moving so slowly that a single orbit around the Sun may be longer than the entire history of human civilization. A small block of ice out there does not need anyone to see it in order to remain part of the solar system story. It only has to keep following an immense curve held by the faint remaining gravity of the distant source of light inside. An object like that can sleep for millions of years. Around it, there is no sunrise in the familiar sense. The Sun is only a bright star among many other stars, a point whose gravitational meaning is greater than its meaning as light. The heat it receives is so small that ancient ices are almost never awakened. Dust settles over the surface. Time does not pass as a day, a season, or a year, but stretches out into orbits so long that every measure of ordinary life becomes small. In that darkness, a comet nucleus may preserve material from the youth of the solar system, like a fragment of memory placed in the coldest possible place, so time cannot distort it too much. Then a very small change occurs. Not a great collision, not an explosion, not a hand pulling it out of sleep. It may be gravity from a star that passed relatively nearby in the distant past. It may be the tidal force of the Milky Way, weak but persistent, acting on the outermost orbits. It may be slow disturbances accumulating over a long time. A slight shift in the path is enough for that object to begin falling deeper inward. It does not plunge down like a stone through air. It slides along a gigantic orbit, taking thousands or tens of thousands of years to move toward the source of light that has held it from so far away. When it is still in the outermost region, it is a dark grain in the old sea between the stars. As it comes closer, it begins to become a comet. The light gradually increases. The warmth is still weak at first, then grows stronger little by little. Ices that have slept for a very long time begin to sublimate, turning directly into gas as the surface is warmed. Dust is pulled along, escaping from the old crust, forming a faint cloud around the nucleus. The particle wind and light from the central star push that gas and dust backward, drawing it into the tail that human beings on Earth may be able to see. Something that was once an almost nameless block of ice at the farthest gravitational edge suddenly becomes a soft streak of light in the sky, astonishing ancient people, giving astronomers something to calculate, and helping modern science recognize that a very distant region is sending a letter back into the inner realm. Long-period comets are not only beautiful sights, they are signs of another ending of the solar system. Not the ending of the particle wind, not the place where the heliosphere gives way to the interstellar medium, but the ending of gravitational attachment. An object arriving from distant darkness, returning after an immense span of time, carrying an extremely long orbit tilted in many directions, tells us that beyond the planets, beyond the more familiar icy belt, there may exist a reservoir so vast that it surrounds the entire system like a cold halo of memory. Human beings call that hypothetical region the Oort cloud. It is not a white cloud that can be clearly photographed through a telescope. There is no image showing a gigantic mist wrapped around the solar system. It is inferred from comets that enter the inner region from many different directions, with orbits so long that their origin seems to lie in a very distant realm, closer to a spherical shell than a thin disk. That region remains a scientific model based on indirect evidence, but that kind of evidence fits the nature of the place it describes. A dark, sparse, distant reservoir does not easily reveal itself. It lets icy messengers enter the light on its behalf. Looking outward from inside the solar system, everything is usually arranged in more familiar rings. The rocky planets are near the source of light. The giant planets lie farther away. The icy regions beyond Neptune hold dwarf worlds and countless small fragments. The heliopause marks the place where the particle wind is no longer the main background. Then the story seems to blend into the interstellar medium. But gravity does not follow the same boundary as plasma. It does not need the particle stream to remain strong, does not need significant warmth, does not need enough light to create seasons. It only needs enough strength to bend an orbit, even if that orbit is so wide that the object almost disappears from every intuitive human map. Voyager has entered interstellar space in the sense that the particle environment around it no longer mainly belongs to the central star's bubble. But ahead of the spacecraft, in the gravitational sense, there is still a much deeper reach. Voyager's instruments will fall silent long before it reaches the region where the Oort cloud is thought to begin. One day, the spacecraft may be only a cold object drifting through darkness, no longer sending signals, no longer being guided, no longer telling Earth anything. It will still carry the shape of human curiosity, but the story of its measurements will end far earlier than its physical journey. That thought makes the distance out there feel quieter. A spacecraft moved humanity when it crossed the heliopause, and yet the farther gravitational edge remains far beyond the lifetime of its instruments. The solar system, when measured by particle wind, has a threshold Voyager could touch within a few decades. When measured by comets sleeping at the distant boundary, it opens into the time of hundreds, thousands, even tens of thousands of years. The same home, but each wall is made from something different. Light, particles, force fields, orbits. Each one fades at its own pace. The Oort cloud carries the feeling of the slowest rhythm. Out there, objects do not need to come close to one another. They may be separated by enormous distances, so far that if you stood on a comet nucleus, the nearest neighbors would not appear as a crowd. It is not like a dense belt. It is sparse, dark, vast, existing almost only in the way orbits are inferred. That sparseness makes the region difficult to imagine, but also more beautiful. A cloud too thin to see, too wide to cross within the span of a mission, too cold to offer a brilliant scene, may be the final part of belonging to the Sunday. In that region, the word belonging becomes softer than any ordinary definition. Near Earth, belonging to the sun means receiving light, warmth, seasons, day and night. Near the giant planets, belonging means orbiting the same gravitational source and lying inside the vast region of particle wind and magnetic fields. Beyond the heliopause, an object can still belong through a gravitational curve, even while it sits inside the interstellar medium. It is no longer enclosed by the star's plasma climate, but it is not yet completely free of that star's pull. A place can belong to two stories at once. The environment around it is interstellar, while its orbit still belongs to the solar system. That overlap makes the outer edge feel less like a border and more like a twilight zone. Not a twilight of light, but a twilight of influence. One layer has already darkened, while another still glows faintly. The particle wind has yielded, but gravity still speaks very softly. The planets lie far inside, but distant icy objects still follow arcs around the same source. The interstellar medium surrounds them, but the solar system has not vanished from their orbits. The ending does not arrive like a door closing. It stretches out, fades gradually, and asks the listener to accept that the universe has no obligation to end neatly for the human imagination. A comet entering from the distant region makes that truth easier to feel. It begins as a dark block of ice with almost no surface life. It falls through distances that light needs many hours, then many days, then less time to cross. It enters the region where the planets have stirred the orbits of countless small objects. it receives more warmth. The ice wakes, dust escapes. A tail opens under the pressure of light and particle wind. On Earth, people may see it as a faint streak in the sky, while most of its life has passed in a realm no human eye has ever directly seen. In that brief moment, the distant edge steps into the inner region. Comets like this make the night deeper. They do not merely decorate the sky. They carry information from a place where light is rarely thought of as a source of warmth. In their composition are ice, dust, volatile compounds, and materials that may have been preserved from the time the planetary system was forming. When a comet moves near the Sun, it gradually loses material while also revealing ancient layers inside. Science looks at the gas and dust escaping from it to understand what once existed in the early disk of material. A thin streak of light can therefore open a path into a very distant past, not through human memory, but through the chemistry of ice. Seen through comets, the solar system is no longer a static structure. It becomes a place that still occasionally receives letters from its outer edge. Some letters arrive after a few decades. Some arrive after a few thousand years. Some are so long that no generation has ever seen both the departure and the return. Each time an object from deep darkness appears, the central region is reminded that it has an outskirts beyond memory. The planets moving steadily through the familiar region do not tell the full age of the home. Comets that travel far and return show that this home has corridors so long that almost no one can walk them to the end. In that very distant place, the Sun can no longer do much with light, but its gravity persists in an almost emotionless way. It does not warm those objects. It does not make their ice evaporate. It does not give them clear seasons or a bright sky. It only keeps them on vast paths, gently enough that an influence from the galaxy or a passing star can change their orbits. That attachment is not strong, but it is durable. A cosmic family can have members so distant that they are held only by the thinnest thread. That distance also reminds us that interstellar space and the solar system are not two absolutely separate labels. Voyager is in the interstellar medium, but if we consider objects still bound to the Sun farther out, the story of the solar system extends even through regions where the background material is already interstellar. Part of the outside can still contain objects that belong to the star through orbit. This sounds strange because human language likes to divide things in two: inside or outside, belonging or not belonging, remaining or ending. Physics at the edge does not divide things that way. It allows layers of definition to overlap, each one true within its own range. A lamp may stop warming before it can no longer be seen. A voice may no longer be heard clearly before the speaker is forgotten. A river may lose the color of fresh water before every trace of it dissolves into the sea. The Sun also has many ways of being present. In some places, it is present through light. In others, through particle wind. In others, through magnetic fields. In others, only through the very faint pull placed on a dark block of ice. When all these layers are placed beside one another, the solar system appears not as a sphere with a shell, but as a song with many notes fading at different distances. In that song, the Oort cloud is among the almost final notes. No one hears the entire arrangement directly. Human beings hear only a few notes echoing back through comets. An object enters the bright region, flares up, leaves a tail, and disappears. From its path, scientists infer the distant place that sent it. From its composition, they read part of the history of ice and dust. From its very rarity, we sense the scale of the outermost region. Sometimes the sparsest things reveal scale most clearly. If, one very distant day, Voyager drifts near that realm, it will no longer be a spacecraft speaking with Earth. It will be a silent fragment of an old civilization, flying through darkness with objects that once slept at the gravitational edge. No one then will need to hear a signal for the journey to still have meaning. The meaning will already lie in the fact that it once helped humanity understand the heliopause, then continued onward into a farther layer of the idea of leaving. Instruments can go silent, but the trajectory still says that this object is continuing its departure. In the central region, Earth still turns, the seasons still arrive, the oceans still receive light, and life still lives within the intimate rhythm of a star. In the outer region, sleeping comets know nothing of that rhythm. They live by the calendar of darkness, only occasionally being awakened to enter the light and then leave again. The same solar system contains both kinds of time, the time of day and night, and the time of orbit so long they almost feel motionless. The coexistence of those two rhythms makes our cosmic home wider than any simple diagram. The edge of the solar system, then, is not a point where we can place a finger and say that everything ends. It is more like a region of memory thinning out. First come the clearly defined planets, then the smaller, darker, icy realms, then the place where the particle breath blends into the material between the stars. Farther still are comets held by an extremely thin gravitational curve. Each layer is less bright than the one before, but none is meaningless. Together, they create the feeling that a star does not end at the edge of its fire, but through very distant traces left behind in the dark. At the end of that reach, the sun is almost only a gravitational promise. It does not promise warmth, it does not offer a scene. It does not make distant blocks of ice become brilliant until they fall deeper inward, but it still holds a few ancient fragments within its wide curve, as if the star has not yet wanted to let go of every memory of its birth. Sleeping comets at the far edge do not need to tell their story through sound. It is enough that, once in a while, a piece of ice returns, brightens in the inner region, and slowly fades as it passes the old source of light. Then human beings understand a little more that the solar system has endings longer than our ability to wait. This slowness does not make science less compelling. It makes the fascination last longer. A beautiful scene may hold the eye for a few seconds. A question opened in the right way can hold the mind for much longer. Why do particles from the outer edge arrive more strongly from one direction? Why did Voyager measure a different environment while the magnetic field did not change in an overly simple way? Why do long-period comets seem to come from a distant reservoir surrounding the whole system? None of these questions disturbs the quiet tone of the story. They are like small points of light in a broad, dark region, enough to make the listener want to continue without feeling tense. The maps being drawn also remind us that the solar system is not only a place of objects, but a place of relationships. The particle wind relates to the interstellar medium. The sun's magnetic field relates to the magnetic field outside. Distant comets relate to the gravity of the star and to very slow disturbances from the galaxy. Cosmic rays relate to the imperfect protection of the heliosphere. If we separate each object out, the story can easily become a list. When we look at the relationships, the solar system becomes a system exchanging with the larger region around it. In the inner region, those relationships are often hidden by familiarity. Daylight is too obvious, the seasons are too close, Earth is too intimate. But messengers from the outer edge give the familiar more depth. The sun does not only rise and set, it creates a particle bubble around the planets. A comet is not only a rare streak of light, it may be a fragment of ice from the distant gravitational realm. A neutral atom is not only a small piece of data, it is a message from the place where the particle wind meets the galaxy. Voyager is not only an old spacecraft, it is a needle mark passing through the outer layer of an invisible home. From the ground, human beings do not see the heliosphere around them. No one wakes up and feels the plasma shell at the outer edge. But a civilization curious enough has learned to extend its senses through machines. Antennas become ears, particle detectors become skin, computer models become the temporary memory of a structure too large to hold at once. Telescopes, watching comets, become a way to read a region that has never appeared in full, not because human senses have little value, but because the universe has more layers than the eye and the skin were made to perceive. There is also a quiet humility in the way this map always remains unfinished. The heliopause is not yet known as a definite line in every direction. The shape of the heliosphere is still debated and adjusted. The Oort cloud remains a strong model, but has not been directly photographed as a clear object. The unknowns do not weaken the story, they keep it alive. A sleep science video does not need to pretend that everything has been closed. It only needs to give the listener the feeling that the unknown also has order, reason, beauty, and is being gradually opened through very subtle ways. The edge of the solar system, then, is not a ready-made picture hanging in front of humanity to be viewed. It is more like a letter torn into countless pieces and sent back along many different paths. One piece lies in the tail of a comet. One piece lies in a neutral atom flying back into the inner region. One piece lies in Voyager's signal. One piece lies in the increase of cosmic rays after leaving the old enclosure. Human beings do not hold the entire letter in their hands, but they have assembled enough pieces to understand that out there is a soft edge, a shell, an interstellar sea, a distant storehouse of ice, and a star gradually blending its private region into the galaxy. When those pieces are placed beside one another, the original question does not become narrower, but wider. Where does the solar system end? It is no longer a question that demands a single number. It becomes a question about how nature leaves traces of an ending. Where the particle wind changes roles, there is one kind of trace. Where gravity still holds comets, there is another. Where interstellar material presses against the star's bubble, there is another still. The ending is not located in a drawn line, but in the changing nature of the messengers that pass through that boundary. Out there, particles continue to fly, comets continue to sleep, cosmic rays continue crossing the dark background. Voyager continues drifting farther away, carrying part of Earth's technological memory with it. Each thing is doing its work according to the laws of physics, unaware of the names human beings have given them. But when those signs touch instruments, telescopes, models, and curiosity, they become a very slow map. That map does not make the edge of the solar system less strange. It gives that strangeness shape, depth, and a voice small enough that the listener has to become truly quiet in order to hear it. Messengers from the outer edge do not only help human beings know how wide the solar system is, they also reveal something quieter. The planets are not drifting naked through the galaxy. Around them is a vast domain created by the central star, a kind of cosmic climate blown by particles, stretched by magnetic fields, and changing with the rhythm of activity from the old source of light. That domain is not a fortress. It cannot block everything from outside. It does not seal Earth inside an absolutely safe room, but that imperfection is exactly what makes it more like nature. A living, soft, changing buffer, both sheltering and allowing the larger universe to pass through in softened ways. Deep inside that buffer, Earth orbits the sun with the familiar pattern of day and night, seasons, clouds, oceans, and life. The atmosphere holds air close to the ground, softens the light, and burns up many small pieces of rock and dust before they reach the surface. The planet's magnetic field bends the flow of charged particles, guides some of that energy toward the polar regions, and lights the auroras. These nearer protective layers are easier to imagine because they leave clear signs in ordinary life: blue sky, weather, sunlight, compasses, and the northern and southern curtains of light. Much farther away, the heliosphere adds a larger layer of context, less familiar, but also involved in the way the blue planet lives within the galactic environment. Cosmic rays from outside do not disappear when they meet the heliosphere. They still enter the inner region. Some particles have such high energy that they pass through many layers of protection before the atmosphere processes them, creating secondary particles and traces that instruments on the ground can detect. But the wide particle wind and magnetic field of the central star change the paths, intensity, and way these particles approach the region near the planets. When solar activity is stronger, the amount of galactic cosmic rays entering the inner region is often reduced more. When solar activity is weaker, they can enter more easily. A protective layer does not have to be absolute in order to matter. Sometimes, simply making the flow from the galaxy less direct, less even, and less intact is enough for it to become part of the cosmic climate around life. This should not be heard as a story of fear. Cosmic rays are not a darkness waiting at the edge. They are a normal part of the galaxy, born from powerful, distant, ancient processes. Earth has lived with them throughout its long history. The atmosphere, the planet's magnetic field, and many other factors together make the surface far more stable than open space. The heliosphere only adds a wider layer to that chain. It does not separate the planet from the universe. It adjusts the way the universe touches the inner region. Protection, in this case, is not closing a door. Protection is making the encounter more structured. Seen this way, the solar system no longer looks like a set of planets lying in black space. It becomes more like a great ship carrying its own climate as it moves through the galactic sea. Inside that ship are rocky worlds near the source of light, giant planets with vast magnetic fields, distant icy regions, comets sleeping in darkness, spacecraft launched by human beings, and a small blue planet with oceans, living things, cities, and voices. Outside the hull is not nothingness. It is the interstellar sea, thin, cold, ancient, containing gas, dust, force fields, and high-energy particles. The heliopause is where the private water stirred by the star meets that shared sea, and the heliosphere is the private water surrounding everything within. An image that is too perfect would lose the truth. The heliosphere is not a glass dome from science fiction. It does not keep the inside untouched like an object placed in a box. The sun has calm days and violent days. Strong particle storms can spread auroras wider, place pressure on satellites, and make power and communication systems need careful monitoring. The outer region of the heliosphere also does not stand still. Its shell is shaped by the interstellar medium and altered by stronger or weaker waves of wind from within. A living shelter like this is both reliable and fragile in a natural way. It does not promise permanence, but it has lasted long enough to become part of the setting in which the planets developed. That long duration is what makes it remarkable. Earth does not need a perfectly quiet universe in order to have life. It needs conditions stable enough for long enough. An orbit that is not too extreme, a steady source of energy, an atmosphere capable of holding warmth and protecting the surface, a magnetic field that helps deflect many charged particles, oceans with time to preserve complex chemistry. And on a larger scale, the whole planetary system lies inside a region created by its star, where the flow of cosmic rays from the galaxy is modified before reaching deeper inward. No single layer creates the miracle by itself. Many layers together create endurance. That endurance is not loud. Most days on Earth pass without human beings thinking about the heliosphere. A leaf opening in sunlight does not know that far away there is a plasma boundary at the outer edge. A child looking at a photograph of auroras may not need to know how many layers of interaction the sun's particle stream has crossed. A person walking in the rain only feels the atmosphere nearby, not the vast bubble of the star moving through the Milky Way. But the distant layers are still there, like less often named parts of a home, not because they are close to the hand, but because they take part in the larger context in which that hand exists. There is a soft beauty in the fact that this home has no clear walls. A hard wall gives a feeling of safety, but it also gives a feeling of separation. The heliosphere does not do that. It has an edge, but that edge exchanges with the outside. It reduces part of the high-energy particle flow, but does not lock everything away. It allows the interstellar medium to leave traces, allows neutral particles to enter, allows cosmic rays to become part of the physical life around the planet. Because of this, Earth is not a room isolated from the galaxy. It is a world sheltered enough to live, yet open enough to belong to the larger universe. That way of belonging matters. Human beings often want to be protected from the vastness because the vastness can make us feel small. But in science, smallness is not necessarily a loss. Knowing that the blue planet lies within many layers of interaction does not make ordinary life less meaningful. It gives a morning more depth. The light on a window does not come only from a bright disk in the sky, but from an active star blowing particles, bending fields, building a region of influence, and carrying that entire region through the galaxy. Every ordinary day unfolds inside a large movement the body cannot feel, but the imagination can learn to touch. In that movement, the sun also becomes less like a still object. It is not only there for the planets to orbit. It swims through a real environment, carrying its family of planets as a private region within the shared sea. From the viewpoint of human beings on the ground, the central star rises in the east and sets in the west, creating a familiar rhythmic feeling. From a larger viewpoint, the entire system is moving through the Milky Way, through the thin material between the stars, with the heliosphere, like a soft chamber blown outward. A place with day and night is also a place drifting through the galaxy. This makes the word home expand in many circles. Home can be the room where a person sleeps. Wider than that, it is the planet with gravity, air, water, and ground. Wider still, it is the orbit around a star stable enough that time is not torn into chaos. Farther out, it is the heliosphere, where the star blows a private climate into the interstellar medium. Each circle does not replace the one before it. The room still matters. The planet is still familiar. The star is still the source of light. But when we know the larger circles, the familiarity of the smaller one does not shrink. It is placed into its proper, wider background. We can hear this in the image of a cosmic ray particle traveling from the galaxy into our region. It may be born in the remnant of an exploded star, pass through interstellar magnetic fields, meet the outer heliosphere, be deflected, lose energy, or continue onward depending on the conditions. If it travels deeper in, Earth's magnetic field may bend its path again. The atmosphere may then turn it into a shower of secondary particles. A long journey from a distant event in the galaxy to the sky of a planet is written through many filtering layers. No layer stands alone. No layer is a fortress wall. But together, they turn a high-energy universe into a surface where rain can fall, trees can grow, and human beings can look upward without being burned by everything beyond. That image is enough to make the edge of the solar system feel closer. The heliopause is not only the place Voyager crossed. It is the outer edge of one of the layers that has made the inner region different from the direct galactic environment. The Oort cloud is not only a distant storehouse of comets, it is a reminder that gravity can still hold ancient fragments in darkness far longer than the lifetime of any civilization. Neutral particles are not only data on a map, they are the way an invisible shell sends news back. All of these elements together make our cosmic home feel less like a location and more like a system of relationships. A system of relationships does not need a single emotional center, but Earth is still where the feeling returns. From the ground, looking upward, the stars seem still. No one sees the heliosphere pressing into the interstellar medium. No one sees the Oort cloud sleeping in darkness. No one sees neutral particles flying back from the outer edge. But science gives that silence depth. It tells us that above the night sky there is not only distance, but layers. The atmosphere, the magnetic field, the particle wind, the tangled shell, the plasma boundary, the interstellar sea, the distant cometary reservoir. Each layer adds another kind of quiet to the feeling of living on a small planet. That quiet does not come from everything being absolutely safe. The universe has never promised that. It comes from the fact that there is order within the vastness. There are mechanisms, there are interactions, there are layers softening one another, there are signs to read. There is the truth that a small living species can slowly come to understand, even the invisible shell around its own star. Fear often grows inside nameless darkness. Here, the darkness has names, data, a story, exploring spacecraft, and particles flying back with messages. When the outer edge is understood as an imperfect shelter, Earth's fragility is also placed in a different light. This planet is not invulnerable. It depends on the balance of many conditions, but it is not alone in a mute emptiness either. It is nested within physical layers, placed inside the private region of a star, surrounded by processes that had been operating long before human beings gave them names. Life does not appear outside the universe. It appears inside the universe, in a corner where many layers of interaction happen to create enough time by chance and by endurance. At the distant edge, the heliopause knows nothing of trees, oceans, or sleep. It is only a balance of particles and pressure, but a very distant balance can still contribute to the setting of very near things. Between the outer edge and a breath on Earth, there is an enormous distance, countless intermediate layers, and many processes that are not direct but are still connected. Those connections are what give space science its own quiet comfort. It does not place human beings at the center of everything. It simply shows that human beings are connected to many things. And perhaps that is the feeling that should remain when we think about the bubble of the central star. Not the feeling of being absolutely shielded, not the feeling of being abandoned in the galaxy, but the feeling of living inside a region that is both private and open, shaped by the sun and touched by the Milky Way. A region stable enough for planets to have histories, thin enough at its edge to receive news from outside, wide enough that Voyager needed nearly its whole mission lifetime to cross it, and close enough that every day on Earth still unfolds beneath the familiar light of the star that created it. That shelter does not shine in the sky. It has no outline for the naked eye, but through modulated cosmic rays, through neutral particles flying back inward, through Voyager's data, and through models being gradually revised, it appears as part of the place where we live. Beneath those layers, the oceans still move, clouds still form, trees still open their leaves in sunlight, and a small planet still turns inside the private region of its star. At the edge, the galaxy still touches that shell with particles from far away. Between those two truths lies the solar system, not a sealed fortress, but a soft refuge drifting through the old sea between the stars. Near Earth, that source of light seems very clear. It rises above the horizon, spreads gold across the sea, warms rooftops, awakens clouds, passes through leaves, and places the rhythm of time upon every living thing beneath the atmosphere. A day begins with light so familiar that human beings can easily forget that the star does not only shine, it also breathes out particles, pulls the planets with gravity, wins magnetic fields into broad spirals, and builds an invisible domain around the entire inner region of the solar system. From the ground, looking upward, the sun is morning. From greater distances, it is a system of influence expanding outward, weakening, and then blending into the shared material of the galaxy. The farther from the center we go, the more that presence changes form. Near the rocky planets, it is warmth, light, and seasons. Near the giant planets, it is a source of particles moving through vast magnetospheres, lighting auroras where atmospheres are able to hold that energy. Beyond Neptune, where the familiar worlds have receded, the particle wind still continues outward, but no longer with the strength it had at the beginning. It is slowed, compressed, and stirred in the outer shell. At the heliopause, the particle breath of the central star thins before the interstellar medium. Beyond that threshold, what surrounds Voyager's body is no longer the old plasma background of the inner region, but the wider material between the stars, sparse, cold, and ancient. That transition offers no scene for the human eye to hold on to. No new color opens up, no wall stands at the end of the darkness, no floating marker announces that a star system has ended. The true edge of the solar system is far more discreet. It lies in the decrease of one kind of particle, the rise of a background of cosmic rays, the change in plasma density, the difference between the region of the solar wind and the local interstellar medium. A small spacecraft has traveled far enough for those changes to touch its instruments. From there, weak signals return to Earth. carrying news from the place where the invisible home of the planets has grown so thin that it almost blends into the galaxy. Voyager does not make the outer edge more brilliant. It makes the outer edge more real. After the great images of the planets, after the swirling clouds of Jupiter, the bright rings around Saturn, and the blue ice worlds lying very far away, the spacecraft continued into a region with almost no scenery left to send back. There, its value is not in images, but in its ability to listen through instruments. An aging machine, weakening year by year, has remained durable enough to record the place where the background around it changes voice. The fewer the images, the more the data becomes like precious grains of dust. Each small number becomes a way for human beings to touch a place where no one can stand. Beyond the main layer of the particle wind, interstellar space is not absolute emptiness. It is the old sea of the Milky Way, a background substance so sparse that imagination can hardly grasp it, yet carrying within it the long history of stars. Hydrogen and helium gas drift between bright regions. Fine dust dims starlight across long distances. Magnetic fields bend the paths of charged particles. Cosmic rays cross the dark spaces after being born in powerful events far away. Mixed into that material are heavier elements, once cooked inside older generations of stars, and then returned to the galaxy. The sun, earth, rocks, water, metals, living bodies, and even the materials of Voyager all come from a chain of material rebirth far older than any civilization. So, the outer region is not only the part after the solar system, it is the wider background from which the solar system once emerged. The central star formed inside an ancient cloud of gas and dust. The planets gathered from the material still orbiting the young star. Earth held water, rock, and atmosphere, and eventually life in a corner stable enough for long enough. Then, from that very planet, human beings took metal from the ground, silicon from minerals, energy from matter, curiosity from the brain, and sent a machine back into the space between stars. A part of the galaxy, after billions of years of transformation, learned how to measure its old sea with a small spacecraft. Even farther out, where light is only a thin trace in the cold, sleeping comets continue to preserve another kind of connection. They do not need to lie inside the main particle wind to still belong to the old source of light. A comet nucleus can be extremely far away, in a region where the surrounding environment already has many interstellar qualities, while its orbit is still held and curved by the sun's gravity. It may sleep through stretches of time so long that all of human history is only a very brief streak. A dark, icy surface, a thin covering of dust, slow motion, silence. Then a very slight gravitational influence from the galaxy or from a star passing by in the distant past may shift its path. That block of ice begins to fall inward, moving closer to the source of light, waking under the warmth, releasing gas and dust, and leaving a faint tail in Earth's sky. A comet's streak does not only beautify the night sky, it brings the farthest part of the solar system back into the realm of human sight. In that brief light is the darkness of a long orbit. In the escaping dust is ancient material. In the tail pushed by light and particle wind is a meeting between the inner region and the outer one. Comet nuclei from the distant realm are like cold fragments of memory kept at the thinnest gravitational edge. Once in a while, one fragment returns, brightens, and disappears again. It does not tell the whole story of the Oort cloud, but it is enough to suggest that beyond the planets and beyond the heliopause, the sun's story still has very faint lines written in orbits. The solar system widens in this way, not through a single boundary, but through many kinds of remaining influence. Light remains in one way, particle wind remains in another. Magnetic fields, plasma, cosmic rays, and the interstellar medium create another kind of transition. Gravity holds distant comets in a still slower rhythm. The same source of light can have many circles of presence, and each circle thins at its own distance. Simple maps want one final line, but nature is softer than a drawn line. It lets layers fade gradually, not at the same time, not in the same form, and not with the same meaning. In the inner region, protection also has many layers. Earth has an atmosphere, a magnetic field, a suitable distance, oceans, rock, and long chemical and biological cycles. Farther out, the heliosphere keeps the flow of cosmic rays from the galaxy from entering the inner region in a completely unchanged way. That enclosure is not absolute, and it does not need to be absolute in order to matter. It is more like a soft refuge than a sealed dome. Some of the outside still passes through. Some is deflected, weakened, slowed, and mixed into other processes. Because many imperfect layers exist together, a small planet can remain stable enough for rain to fall, trees to grow, oceans to move, and life to have time to learn how to look upward. The peaceful feeling of the solar system does not come from being separate from the galaxy. It comes from existing within the galaxy while still creating a region of its own. The central star is not a fortress, and it is not a powerless point of light. It is an ordinary but enduring sphere of plasma, stable enough to hold the planets for billions of years, active enough to blow out a vast region of particles, close enough to warm Earth, and strange enough at the outer edge that human beings have to send probes and read very small data in order to understand it. That ordinariness does not make it less wondrous. It makes the wonder gentler, closer, and more lasting. From the ground, that star is sometimes only sunlight cut by a window into a small stripe, a red afternoon on clouds, the shadow of a tree leaning across a road, the heat left on a rooftop after a long day. But that same source of light also has a region of influence larger than any everyday scene. Its particle wind has traveled past the planets, through icy regions, and into the tangled shell far away. Its heliopause lies at a distance too great for a human lifetime to feel by intuition. Its comets can sleep in darkness, through spans of time too long for history to remember. An ordinary morning, then, does not belong only to that day. It belongs to a many-layered system drifting through the Milky Way. Messengers from the outer edge give that system a voice. Comets send news through light and orbit. Neutral particles send news through direction and energy. Cosmic rays send news through their rise and fall as they pass through the star's enclosure. Voyager sends news through measurements taken around its body. No messenger carries the whole truth. A particle is too small, a comet too rare, a spacecraft passes through only one slice, and a signal comes from only one direction. But when many signs are placed beside one another, the darkness begins to have structure. The outer edge is no longer the nameless black beyond the planets. It has layers, a soft boundary, an interstellar sea, a distant cometary reservoir, and ways in which the sun's private region exchanges with the shared background of the galaxy. That understanding does not close the mystery. It gives the mystery depth. A region not yet seen directly, like the Oort cloud, can still become a reasonable part of the story through long-period comets. A boundary that cannot be photographed by the eye can still be confirmed through plasma and particles. An invisible shell can still be mapped through neutral atoms flying back inward. Science does not take beauty away from darkness by naming it. It makes the darkness less silent. It gives the far distances a grammar. So human beings do not only look upward, but can also understand part of how those distances are connected to the place where we live. One day, Voyager will no longer send signals. Its power source will weaken, its instruments will gradually shut down, and the antennas on Earth will no longer catch those faint pieces of news from the spacecraft's body. But that small object will keep moving. It will become a silent fragment of an old civilization, carrying within it metals from Earth, traces of technology, and the memory of an age that believed a tiny spacecraft could ask the universe very large questions. When it can no longer speak, it will still be an artificial point drifting through the interstellar sea, an object born in the bright region and then left for the darkness to keep. In the distant region, comets still sleep to the rhythm of gravity. In the inner region, the planets still orbit. On Earth, the day still opens with familiar light, clouds still change shape, Water still rises into vapor and returns as rain, and leaves still receive energy from the central star. These intimate things do not stand apart from the heliopause or the interstellar medium. They belong to the same story. A green leaf and a neutral atom from the outer edge are separated by an unimaginable distance, but both belong to the system of a star blowing its private region through the galaxy. The place where the private blends into the shared does not need to become tragic. The solar system does not disappear when the particle wind grows thin. It simply touches a larger sea. A lamp in mist does not end at the clearest edge of its light. It also has a faint glow, a thin warmth, a region of color almost dissolved into the night. Our star is the same. It has the brilliant center, the stable region around the planets, the chaotic outer shell, the far realm where comets are still held by gravitational curves, and finally the blending into the galactic background. The ending here is not loss. It is a transition from a private home into the wide space that has always surrounded that home. The night sky, then, becomes deeper without needing to become brighter. Between the stars there is not only distance, there is sparse material, there is dust, there are magnetic fields, there are high-energy particles, there is the history of dead stars and new stars. There are regions of influence from individual stars swimming through the shared background. In one small corner of that sea, the solar system carries it, with Earth lying deep inside layers of protection and interaction. From the ground, looking upward, we see only points of light. But behind that silence are many soft motions, many meetings between particles and fields, between light and dust, between orbit and time. Far away, the old source of light becomes a thin memory. For Voyager, it is the place of departure, the point of brightness behind it, the reason the spacecraft has a direction to leave behind. For an Oort cloud comet, it is the pole that still holds its path in the cold. For Earth, it is day, seasons, water, trees, sky, and life. The same star, but distance changes the name we give it. Near, it is warmth. Far, it is thinness. Very far, it is only a curve in the dark. That changing of names does not make the star smaller. It lets us see that a source of light can touch the universe through more layers than the eyes ever knew. The edge of the solar system, in the end, is like a very large twilight. Not the twilight of an evening, but the twilight of influence. Light continues on. The particle wind weakens. Plasma changes its background. Particles from the galaxy become clearer. Comets preserve cold memory. Gravity draws the final curves through the darkness. There is no sound of closure, only layers changing color very slowly. In that twilight, our cosmic home does not become a lonely streak. It becomes a private region gently dissolving into the sea of stars, still holding its traces long enough for a spacecraft, a comet, a tiny particle, and a curious mind on Earth to recognize them. And somewhere very near, beneath those invisible layers, a person can close their eyes at night without needing to see the heliopause, without needing to see the Oort cloud, without needing to hear Voyager's signal. Those things are still out there, quietly forming the background of the sky. The solar system does not end with a sharp line. It fades through light, through particles, through orbits, through material memory, and through small signs returning from the darkness. That fading is what makes it more beautiful than a clear border. A home with a soft edge is still a home. A source of light dissolving into the sea of stars still leaves enough warmth in the inner region for life to look upward and listen.